Okay. So let us start at question 10 with this question. So you have two screens there. One screen I want to be able to see diagrams and stuff while I'm working on the right screen. So I tend not to work on the screen on the left. I must be doing the work on this screen on the right. All right. So let's go. So this question gave us question 10 gave us a transformation. This is the transformation matrix, and it says this transformation M up to the point P onto the point P prime. So it's this point onto that point, right? And what I want us to do is let's go on to the next page. I want us in the first part to determine the value of P and Q. Right, so we can go back to the previous page and note the coordinates of the points. So we can use the coordinates of the points to do the calculation. So if we look at the diagram right here. You see that P, now R is a point 2, -5, and R prime is a point 5, 2. All right. So R is a point 2, -5, and R prime is 5, 2. All right. So let's go to the next page now. So the matrix that we're using is the matrix. So it means that M times R equals R prime. All right. Right, that's like a smaller. Yes, and the transformation. M times the point R equals R prime. So it means that the matrix 0, P, Q, 0 times the matrix for R will work again to R prime, which is 5, 2. All right, so basically you can set out this as two equations. Now remember, when you multiply matrices, we're using the rules of the first matrix multiplied by the column of the second matrix. All right, and what will happen here now is that the first row, this first row times this column will be equal to this value. All right, so it means that 0 times 2 plus P times -5 will be equal to 5. This means that minus 5P is equal to 5. And so P is equal to 1. And similarly, this row times the column is equal to this value.
Sir, -1.
-1. Thank you very much. All right, so somebody paying attention. -1. All right, and then, right, as I was saying, this row times this column equals to the 2. All right, so it is Q times 2 plus 0 times -5 equals to 2. And this tells us that 2Q is equal to 2, and so Q is equal to 1. So those are the two values. P equals -1, use a different color for that. For the answer. So P equals -1 and Q equals 1. So basically the matrix M is therefore 0, -1, 1, 0. That is the matrix. All right. Now they're asking us here now to describe the transformation. And the greatest way to describe a transformation is to actually know what it is. All right. Now, if you know this matrix, you know it's an anti-clockwise 90-degree rotation matrix about the origin. And you can just write that if you know it. All right. But if you can look at the diagram, so if I'm looking at the diagram on the right, over here, you see that this point goes through a rotation of 90 degrees about the origin here. So that is what happened. All right. So we can basically write that. So coming back over here, M is an anti-clockwise and anti-clockwise (90°) rotation about the origin. Remember, when you're describing a rotation, you have to give the three components of the rotation. So you have to give the name, which is rotation. You have to give the angle, the direction. You have to also give the center in your description. So basically, that is it. All right? You have to do those things when you're describing a rotation. That is that part. All right, so the next part now is this vectors question. All right, so let's look at that over here. The vectors question. All right, so the vectors question, it gives us this parallelogram. So remember, it's a parallelogram. So the vector parallelogram. Remember, the opposite sides are equal in length and parallel. So the opposite sides of the parallelogram are equal vectors. So before we start doing anything, we know since it's a parallelogram, PQRS is a parallelogram, PQ is U, and PS is V. We can see that on the diagram. So you want to put those on from now. So this vector, let me use the red. This vector is V, because down here is V, and this vector up this way is U. All right, so we know that off the bat. And then they told us that M is on the point, on the line, such that the ratio of QM to MS is 1 to 2. So we can do that information is put the ratio on the line. So this is 1 part to 2 parts. 1 part to 2 parts. All right? And so what it means is that the line has 3 equal parts. And therefore, QM is 1/3. QM is 1/3 of the line. And MS is 2/3 of the line. 2/3 of the line. All right. So basically, then once you have that information, you're good to go. First part wants us to get the vector in terms of U and V. Meaning U and V must be in the answer. They want the vector QS. So all we have to do is look at the diagram and see how we go from Q to S, going along the vector directions that we know. So if we look at the diagram, going from Q to S, we would go here first and then go down here. That's how we go from Q to S. Simple as that. All right. And so it will be equal to QR and then RS. And then the QR is clearly V, and the RS is in this direction, opposite to the U. The U is going up, the U is going this way, but the RS is going down this way. Right? So to account for the fact that they're going in opposite direction, you're going to put minus U. Minus U. So let me underline the vector components. I always go to underline the vector components. So you know these are vectors. Alright. So basically that is the answer. QS is V minus U. Alright. Then the next part now is asking us for QM. Remember, QM is this little piece right here. And we say that is 1/3 of the whole thing down here, QS, right, based on the diagram. And we already know what QS is here, so we can use that information, right? So it means that this QM is equal to 1/3 of QS. Simple as that. And the QS is this. This is QS. So that's what we're going to use. So we're doing 1/3 of that. And so it becomes 1/3 V minus 1/3 U. Because this would be 1/3 of V minus U. And so it's 1/3 of the V minus 1/3 of the U. All right, that is the answer here. All right. Moving on to the next part. Still only have those 20 persons. All right. The next part now wants us to show that MR is equal to 1/3 U plus 2V. That is MR now. So let's look back over this side. So look over this side. You see that they really want us to now find this vector MR. That's the vector that they want. So we go from M to R. What we can do, we can come down to S first and then go up here. And the reason why we're going in those directions because we know the vector QS and we know the vector RS. So it's good to use that information. All right, so let's look at the diagram now and say the MR that we want is equal to MS plus SR. All right, and we know over here that this vector is U and this vector is 2/3. Well, it's 2/3 of the line. All right, this is 2/3. 2/3 of the line. Let me not write that. Right, but this side is 2/3 of the line away, but that vector is U. So the MS is 2/3 of QS. So the MS is 2/3 of the QS plus the SR. Look right now what we know for the side here. What we know is that the QS is V minus U. You know that. And the SR is U.
Sure.
So this calculation becomes 2/3 V minus 2/3 U plus U. So this right here is the first term, 2/3 QS. That's what that is. All right. And then now remember proving that thing. So this therefore becomes, look at it now. Let me remove the brackets. Look at it now. We have this whole U minus 2/3 U. So a whole U minus 2/3 U give you 1/3 U. Yeah. So this becomes 2/3 V plus 1/3 U. And then this answer up here that we're trying to get, what they have basically done is factorize 1/3. So to factorize the 1/3, we're gonna get 2V plus U.
So you're good.
Because you factorize the 1/3 out of this, you left with the 2 inside here. All right. So that is the answer. So that is shown. All right. They have U plus 2V. We have 2V plus U, the same thing. Basically the same thing. All right. All right. The next part now tells us that T is the midpoint of PQ. So let's put down the T over here. So T is the midpoint. So T is the midpoint. So T is like right here. So that's where T is. I'll put it different. So this is T. This point is T. All right. And it says we have to prove that R, M, and T are collinear. So R, M, and T. Prove that that is a straight line, R, M, and T. So remember, to show that R, M, and T are collinear, to show that we have parallel vectors with a common point, we need to decide which two vectors we're going to use. All right. So the vector that we have already to use is the MR. So we have MR already. Right? We have MR already. MR. All right. So we have MR equals, I'm going to use back this so the values are separate, right? Instead of bracket it. MR is 2/3 V plus 1/3 U. And we need another vector. So the other vector we need is a vector with the T. So either we're going to use TM or we're going to use TR. So which one of those is easier to find? TM or the TR? I want to use the easier one. The easier one to find really is TR because we know that this,
So
look at this diagram. This, somebody mute your mic, please. Mute your mic.
You see, how old are you? So rank him set, rank him set.
Mute your mic. Right. So if you look over here, we want to either use TM or TR. So you'll see that TM actually is, TR is actually easier to find because this is half U, you know. From here to here is half U. And this is V. Right? So TR is easier to find than TM. So it's better to use TR rather than to use TM. All right, so we're going to use TR. And if you look at the diagram, the TR is simply equal to half U plus V. Half U plus V. All right, so we're at the stage now where we're trying to eliminate the fractions. Remember, when you show that they are parallel first, you get rid of any fractions. That's the first thing because the fractions make it hard to see the relationship. After you get rid of the fractions, you multiply up the small one to equal the large one, and then you equate. Those are the 3 steps we discussed in class. First thing you want to do is get rid of fractions. So to get rid of fractions, out of this first one, multiply by 3. Right? Multiply this first one by 3. Multiply this first one by 3. We're gonna get 3 MR equals 2V plus U. Somebody still talking. You don't know that when you come on a thing like this, you cannot be talking. All right. Right, so multiply that one by 3, we get rid of the fractions. All right. And then this one over here, to get rid of the fractions, we multiply it by 2. We multiply this one by 2, fraction gone. Multiply this one by 2. The reason I want to get rid of the fractions because the fractions make it more difficult to see the relationship between the vectors. You want to show that one is a multiple of the next and that there's a common point. So multiply the second one by 2, all the fractions will be gone. Right? And so when you multiply this one by 2, you're going to get 2TR equals U plus 2V. So you know, we realize now that you can equate. You don't need to multiply up anymore, right? Because you can now equate. Because this is U plus 2V, but this also is U plus 2V, right? Even though they turned the other way around. 2V plus U is the same as U plus 2V. And then once you have that now, you know that you can equate. So we reach a step now where we're going to equate. So we equate All right, and when we equate, we'll see that 1 is a multiple of the next. When we equate, we're going to get 3 MR equals 2 TR. Right? And I always advise the students to underline the common point. That's a common point. And you tell the examiner what happened here. What is happening here now is that you have parallel vectors. What is happening here now is that you have parallel vectors. So you tell the examiner MR parallel to TR as the first condition for collinearity. Second condition, this is 1. Let me erase that and write it properly. 2 conditions you need for collinearity. 1, you need parallel vectors, and that is MR is parallel to TR. That's the first condition for you to have collinear points. The second thing you need is a common point. And in this case, the R is a common point. R is a common point. And since you have those two conditions, you can draw the conclusion. Therefore, the 3 points involved are collinear. R, M, T are collinear. Collinear. That's how you show that they are collinear. You have to show those 2 conditions. You can see it on the diagram over here that they are collinear. All right. So basically, that's that question. All right. So that's question that finishes question 11. All right. Remember, if you don't understand something, you can just chime in right away and let me know. All right. Guys, you need to mute your mics if you're not speaking. All right. All right. So moving on now to question number 9, working backwards.
Sir.
Yeah.
Somebody having difficulty joining the chat, sir.
Somebody
is having a difficulty
joining
the chat.
Somebody having a difficulty trying to join?
Yes, sir.
But me can't control that. Me can't do nothing about that. But I mean, is the link. There's no password on the link. They just need to click on the link.
Them join it now.
They got all right. Good. All right. Good. All right. So we're going over now to question 9. All right. Question 9 now. Question 9. Right. So let's go question 9 over here as well. Question 9. All right, so question 9 starts with a circle theory question. On Sunday, I went through the rules. I'm not going to go through the rules now. Just need to practice. All right. So this question gives us this circle. So the circle shown below has a center O and the points A, B, C, and D line on the circumference. So the straight line passes through the points A and B. All that is on the diagram. Straight line passes through the point A and B. And the angle CDD is 49 degrees. That is on the diagram. And the angle OAB is 37 degrees. So everything that they have said is on the diagram. All right. This straight line passes through the center right here. So you know that's a diameter. So the diameter rule might come into play there. And this line and this line equal, because each of them is a radius. And so this triangle is an isosceles triangle. All right, so all that information you want to pick up from before you even start doing anything. All right, so let's see what they want us to say. First thing they want us to do is write down the mathematical name for the straight lines BC and OR. So BC, this is BC right here. BC is a chord. A line joining 2 points on the circumference is a chord. So BC is a chord. And then the line OA. The line OA is this one. Any straight line between the center of the circumference, from the center of the circumference is a radius. So OA is a radius. It's a radius. Remember the word radius has 2 meanings. Radius is the physical line, but radius also is the length. The length of the line is also called a radius. So the word radius has two meanings. In this case, the word radius is taken to mean the physical line and not the length of the line, but it's still called a radius. All right, so that's the first part. All right, what else do you want us to do? Let's go over to the next part. Then I want us to get some angles, and that's why I have to keep the diagram over here. All right, so the second part now wants us to determine the value of each of the following angles. We have to show detailed workings and give reasons to support the answer. So basically the reasons used are the 7 rules. The first angle that I want us to tell them is the angle right here. The angle at the center. Right? The angle right here. Right? X, that's the angle at the center. Now that angle is an angle in the isosceles triangle. We said that this is an isosceles triangle. Right? Because this side and this side equal. And therefore this angle is 37, so this angle also is 37. Alright, that's the premise on which we'll find that angle. Alright, so let's write it. This angle is 37 degrees because it's an isosceles triangle. And if you know one angle in an isosceles triangle, you're blessed. You can find the other two. And then now the total angle in the triangle is 180. And so the x will be equal to 180 degrees minus the sum of those two. Alright, so the first thing you have to tell, if you can show them, is that angle. And I say, I'm going to show the reasons, you know. I'm going to say that angle ABO is equal to angle BAO, which is 37 degrees. And the reason for that is isosceles triangle. Isosceles triangle. Isosceles triangle AOB. AOB is an isosceles triangle, that's the reason. And then you're going to say the angle X degrees is 180 degrees minus the sum of those two, which is, I can just write 2 times 37 if you want. Right? So minus 2 times 37 degrees. And somebody can write that out for me. So a calculator here.
So the answer is 106
106
degrees.
Yeah. 180 minus. Alright, so X, that is 106 degrees. Now watch this now. You cannot put 106 degrees as your answer. If you put 106 degrees as your answer, you're going to lose a mark. Right? The angle is 106 degrees. The question asks for the value of X. The question already told you that the angle is X degrees. The angle is X degrees, and so the X is just a value. Right? And so you have to write, therefore, X is 106. Everything important. You cannot say X is equal to 106 degrees. All right? Everything is important. The next part now wants us to find Y. So let's clear this diagram. You know that this is 37 degrees. As soon as you find an angle, put it on your diagram. So that is 37, and this is now 106. This is 106 degrees in there. All right, the next angle I want us to find is the angle Y. That's this angle right here. Now that angle is inside this triangle, which is a right angle triangle. Now why is this a right angle triangle? Because the angle up here is 90 degrees. The angle up here is 90 degrees because it is subtended by a diameter. Angle subtended by a diameter is 90 degrees. All right, and then total angle in triangle is 180. So that's the premise on which we can find the Y. All right, so we can tell the examiner angle BCD equals 90 degrees. It's telling him that this angle up here is 90 degrees. Reason, angle subtended by diameter and the diameter is BD at point C is 90 degrees. That's the reason. Because it's subtended by a diameter. Remember, you know, the questions you have to give your reasons. You cannot just write down angles and stop it at that. You have to show the reasons. Then now, y degrees. Oh, by the way, up here, we didn't say total angle is 180, so let's go back and write it. We didn't say it, We didn't say it. When we said the x equal this, we didn't put the reasons. Up here, we're supposed to say total angle in triangle ABO is 180 degrees. That's the reason for this. All right, so you need to show all the working. Don't leave out anything. So now we're gonna say y degrees is equal to 180 degrees minus the 90 degree angle there, and also minus the 49 degrees angle. I could have just said 90 minus 48, 90 minus 49, right? And so that is 41 degrees. So y degrees is 41 degrees. And so if y degrees is 41 degrees, it means that the y value is 41. The angle is 41 degrees, so the y value is 41. Because the question did say the angle is y degrees. All right, if you put the degrees on it, you're going to lose a mark. Everything important. All right, so that finishes that one. So let's move on to the next part now. All right, so the next part now is this tricks question. Next part is this tricks question. All right, it's a bearings question actually. Once you see a diagram with those north lines and stuff, you know it's bearings. Right, you automatically know that's bearings. All right, let's see what they're saying now. So the question said, the diagram below, not drawn to scale, shows the route of a ship cruising from P, Palm City, to Quayton, Q. So it's from P to Q on the diagram, and then to Rivertown, which is R. So it's from P to Q to R. The name of the city is not really relevant. All right, it said the bearing of Q from P is 133 degrees. Why is the bearing from Q from P 133 degrees? And I gave it away by putting it on the diagram. Remember, bearings is the clockwise angle from the north direction, right, at the from position. So it's like you're at the from position, you face north first, and it is the angle through which you have to turn to the right to face the place that you're going to, right? So if you look at it, this is the north line right here, and you have to turn to the right 133 degrees at the from position P to face Q. That's why the angle there is the bearing angle 133 degrees. All right. Some questions they'll tell you to actually some questions they'll tell you to show the angle instead of put it on the diagram for you. All right, so that is on the diagram. And then the angle PQR is 56 degrees. That's the angle inside here. It's 56 degrees. And the first part wants us to calculate the value of W. See, the value of W. So again, W is just a value. The angle there is W degrees. And so the W is just a value. So you're not going to put any degrees on the answer there. The W is just a value. So we're going to get that angle. It basically sort of help us by marking out this angle for us without putting any angle in there. To know this angle here, we can say total angle on a straight line through this point is 180 degrees. Total angle on a straight line through a point is 180 degrees. All right, so that's the premise on which you can find it. But the question is, how do we get this angle here? So that angle is the internal or the U angle with this one up here between these two parallel sides. So these two parallel sides are joined by this line, which is called a transversal, and the two angles inside here and inside here are supplementary angles, or U angles. So the U angles are the internal angles between those parallel lines are supplementary, meaning they add up to 180 degrees. That's the premise on which you can find that angle there. Right? So this angle here now, you can mark it on the diagram, is 180 degrees minus the 133 degrees. 180 degrees minus 133. And so that is 47 degrees. So that angle is 47 degrees. And then this angle down here now is 180 minus the sum of the other two because of a straight line. So the reason for this one is the U internal angles. The internal, which we call U angles, are supplementary. Supplementary means that they add to 180 degrees. Right? So these two angles are supplementary angles. They add to 180 degrees. And that's how we get that one. Alright, and then for this one now, we're going to use total angle on a straight line. Right, so the total angle on a straight line right here now. Total angle on a straight line over here is 180 degrees. Alright, so total angle on a straight line is 180 degrees. So the W degrees is 180 minus the sum of those two. The 47 at the top there and the 56. Alright, and so it's 180 minus 47 minus 56, which is 77. So W degrees is 77 degrees. Therefore, the W is 77. All right. So basically, I've put all the information there. You don't basically want to write it down, but I wanted to show it on the diagram. All right. So that is how we get those angles. And I'd advise you take your pictures that might have to erase what is on the screen right now. But let's move to the next part. Maybe we can put it over here. This angle right here is 47. Let's put it over here. This is 47 degrees, and this is 77 degrees. 77 degrees, right? So that's what we know. Let's move to the next part. So the next part now is on the next page. So the next part wants us to calculate the bearing of P from Q. Remember, when you're measuring bearing, you have to highlight the from position because the bearing is measured at the from position. You want the bearing of P from Q. So what is the bearing of P from Q? Let's put it over here now. Let's use a different color for bearing of P from Q. So like you're at the from position, right? And you face north first. This is the from position Q. Face north first. This angle through which you have to turn all the way around to the right until you're facing P. So the angle that I want is that angle that I've marked right there. Right? That's the angle that I want. That's the angle that I want right there. How do I get the mark? How do I get the thing on the second? I don't remember. Anyway. Right, so this is the angle that I want, that I've marked. Right? Face north first, which is the north direction up here, at the from position Q, the angle through which you have to turn all the way around to the right. It's a clockwise angle all the way around to the right here. That is the from position. That is the bearing angle that I want. And the bearing angle that I want, you can just basically look at it and break it down. How you break it down is by extending this line down and break the angle. All right. What you find then is that the piece over here is 180 degrees. Over here is 180 degrees. And then inside here is 77. And then this little piece is 56. And so that's how we get the bearing. All right. Let me just go back over that one more time. All right. Let me clear it again. Right. So you want the bearing of this point from this point. All right. So you have to face north first. You have to face north first at the from position. That's the from position. Face north first. And it's the angle through which you have to turn to the right. Angle through which you have to turn to the right. What's that mean here? Oh. The angle through which you have to now turn to the right to face P. That's the angle, that's the bearing angle of P from Q. And if you can't see that angle right away, all you need to do is extend this line down and break the angle into parts. When you break the angle into parts, you see that the piece from here to here is 180 degrees. It's 180 degrees. Then the piece inside there is 77 degrees that we calculated. 77 degrees from here to here. And then clearly, this piece now is 56. So that's how we get the bearing of P from Q. Right? So you would draw that on the diagram and show the examiner. Right? And so the bearing of P from Q would be equal to 180 degrees plus 77 degrees, which is a W, plus the 56 degrees inside here. Alright, and so we work that out. 180 plus 77 plus 56 is 313 degrees. Another way we could have found it is our knowledge of this angle here. Right? Where is it? Let me show you another way we could have found the angle. We could have stated what the angle is. Show you another way. So we worked out that this angle inside this is 47. This angle. So I'm going to clear the diagram and show you another way. We worked out that this angle is 47 degrees. Alright, so if I show the bearing angle that I want again, which is all of this angle around here. Right? We could have said, okay, if our total angle around a point is 360, so this angle that we want would be 360 degrees minus 47. And get the same answer, 300 and what did we get? 313 degrees. So that's another way we could have gotten it, the angle, the bearing angle, because we knew that this piece inside here is 47. All right, so we could have gotten it that way as well. All right, so let's move on. So whichever way you want to do it, we can show it. So we can say or it is equal to 360 degrees minus the 47 degrees that we had before, which would be still 313 degrees, 313 degrees. Anyway, do it to get the marks. That is the bearing angle right there. All right, next part now wants us to calculate the distance, PR. So coming back over on this diagram again, let's clear it again. So we want the distance PR. So we're going to come and work in this triangle now to find PR. PR is this length over here. Right? So we're working a triangle that is not a right angle triangle. Once you're working a triangle that is not a right angle triangle, you have to use either the sine rule or the cosine rule. This is a typical case for the cosine rule because we have two sides. We have two sides, two known sides, and a known angle between them. That's a typical case for the cosine rule. You use the sine rule when you have a known side and a known opposite angle. Side and angle opposite each other, where you know both of them. That is when you use the sine rule. Alright? Alright. So, because we have this now, we can just cosine rule. So, I want to say cosine rule. Cosine rule for PR. Using the cosine rule to find PR. How the cosine rule go again? Cosine rule for PR. Alright, so how it go? Side opposite.
RP.
Huh?
It's RP, sir.
RP, PR, same thing.
Okay.
Alright, not a big issue. RP, PR is the same thing. Alright, so I'm writing it out them of it then. RP. Not a big deal, don't make a difference. Don't matter. So let's write it. RP. So it will make a difference. Anyway, so the RP squared equals this side squared plus this side squared, which is a 210 squared plus a 290 squared, minus 2 times the product of those two sides, 210 and the 290.
So we have a degree instead of a square.
Then the cosine of the angle between them. Yes, I was degree should have a square. Then the angle between, you know, where that become here noise, you know, distract me. You guys need to mute your thing if you're not saying anything. If you're coming to say something like this person a while ago, fine. But generally speaking, mute your camera, mute your microphones, please. I wonder if some people listening because they're not muting. You need to mute. You need to mute. Every time I hear an extra sound, and it, you know. Anyway, so this is now 56 degrees. All right, and you put everything in the calculator and you work it out. You don't have to go working it out piece by piece and waste time. Just work out everything in the calculator all at once. And you know that the RP is going to be equal to the square root of whatever that value is. You don't have to waste time working it out piece by piece. You're not getting any extra marks for that, right? You're not getting extra marks for working it out piece by piece. That is waste of time. Use a calculator, type in everything in the calculator properly, look at it, right? And then you write what the value is. So times 290 times the cosine of 56. All right, and I'm getting
245.
all right, so I'm getting 50. Let me check. 61.76, for example. That's enough, and you square root that. How much I get?
245. 245.
I'm not getting 245. I'm typing something wrong then. Let me go again. 210 squared plus 290 squared minus 2 times 210 times 290 times the cosine of 56 equals. I'm not getting what you guys got to know. Square root of the answer. I'm getting this.
113 kilometers.
I'm getting 224.
Sir, that means you get 2.85.
0.85 something. So you normally can give your answer to 3 significant figures. So I would say 200 and say if based on the fact that I gave you these distances to the nearest kilometer, you can give you a bad answer to the nearest kilometer. So it will be 225 kilometers. So check your answers, please. Check your calculation. Check your calculation. All right. So that is that. Let's see what else they want us to do. Check your calculation, guys. Check your calculation. All right, so that ends that question there. So that's question 9 finished. All right, so let's go back now to answer. It's question 8, right? Yeah, question 8. All right, so now at question 8. All right, here. All right, so the first part of question 8 is a simultaneous equation where one is a curve and this one is a line. All right, and remember, we're solving simultaneous equations of a line and a curve. We tend to use substitution and not elimination. Sometimes you can use elimination, but most times you have to use substitution. Now, this one is pretty straightforward because they have made x the subject of this one and also x the subject of this one. So if this one equals x and at the same time x equals this, then we can just equate these two things. All right? You can just equate them. So at the point of intersection, those two things will be equal. That's what simultaneous equations mean, that you're finding the point of intersection. When you solve equations simultaneously, what you're actually doing is finding points of intersection. All right, so we can say solving them simultaneously, right? It means that at intersection, it means that the y squared plus 2y plus 11 will be equal to 5 minus 3y. But understand that, because we have substituted for x. You can write it over here. Sub for x. Sub for x. We sub for x, that's what we're going to get. We sub for the x. All right, and then we're solving this. Now remember, to solve this, you bring it to a quadratic equals 0. So you transpose everything on one side equals 0. You have to bring it to the standard form before you try to solve. All right, so let's transpose everything. So the only y squared term in the equation is this one, so it remains as y squared. And this negative 3y comes over and add to this to give us a positive 3y. So we're going to get positive 5y. The 2y and the 3y gives us 5y. So we get plus 5y. Then this 5 comes over here and subtract 11 minus 5. 11 minus 5 is 6. So we get a plus 6 equals 0. And then it's a matter of factorizing this. Now there's a question we're going to go through the process of factorization. So I'm not going to stop to do that here now. Right? I'm just going to factorize this. But this one easy because the factors of 6 that add to 5 are 3 and 2. So this one kind of easy to factorize. All right, so this one factorizes easily. And so we get y, 2, and 3. Signs are the same. They are both positive. This means that the signs in the bracket are the same. This means that they are both positive. All right, so we'll have positive signs in the bracket here. All right, so this is a plus, and this is a plus. So it means therefore that y equals negative 2 or y equals negative 3. Everybody understand? I'm going to get the y equals negative 2 or the y equals negative 3. Everybody understand that? All right, good. So moving on. I don't waste any time on that. And remember, I don't stop there. People tend to stop here sometimes. You have to go and find the corresponding x values. But we are found so far are the y values. We are solving simultaneous equations there. So we have to find the x values as well. Plenty of people make the mistake all the time and stop. So to find the y value, we're going to substitute in the x equation. In the x equals 5 minus 3y. We're going to substitute in this equation. All right. Firstly, when the y equals minus 2, the x is 5 minus 3 times minus 2. Now note that the minus 3 and the minus 2 really equals plus 6. So it's really 5 plus 6, which is now 11. So this is equal to 11. And when the y equals, the other y value is negative 3, the x equals 5 minus 3 times negative 3. And this right here is just a positive 9. Minus 3 times minus 3 is a positive 9. So you're really adding 9 to the 5. Right? So the 9 and the 5 is 14. Now, what you want to do sometimes is state a solution. All right, you have to be careful. You have to be careful sometimes. Always state the solution. All right, now because we calculated the y values first, some person might make the mistake and put the solution as the 2 points of intersection as negative 2, 11. And this one, gotta calculate the negative 2 first. But this is wrong because you have to put the y value second in the bracket all the time. You have to be careful. That's what happened with some people in this exam because they calculated the y value first, they put first in the bracket. No, the x value must always come first in the bracket. All right, so the correct way to write the solution for that point is 11 negative 2, and the other one is 14 negative 3. Some persons, what they will do is just write it. X equals 11, y equals negative 2, x equals 14, y equals negative 3. Either way you write those, you'll give your answer. The question that asks for coordinates, up here the question could have said, find the coordinates of the point of intersection of the line and the curve. If they ask for coordinates, then you must give this. If they ask for coordinates, you must give that. All right, this one just says solve, so it's okay. All right, leave it like that. All right, so any one of those you write will be the answer. So it will be this, or we could write our answer as that. All right, so these will be our answers presented any one of those two ways. All right, that is that part. Moving down now to the next question. So next question now is a functions. Well, actually is a quadratic functions. Now, There are some persons in the group here now who will see me do this question in a method that we learn in our class, but that is not taught anywhere else. All right, once you do it and you get the same answer, no problem. So we're gonna continue to do it the way we do it in class, and I've explained in class why we do it the way we do it. But that means that most time when they give you these quadratic functions to complete the square, this is to complete the square, right? They want us to write it in this form. This is called a vertex or the turning point form of the quadratic function. This is a standard form. They want to convert from this standard form to this vertex or turning point form when you form the perfect square. All right. So a lot of times in CXC and some exam paper, what happened is that some teachers they teach a formula for H and they teach a formula for K. The problem is that sometimes in the exam they put a minus here instead of a plus. They put a minus. Sometimes instead of a H they put a here or a B there. Sometimes they'll put a sometimes they put a P here and a Q there. Right? All kind of different variations they use all the time to present the question. Because they're always varying how they present it, what we tend to do is use f of x equals a into x minus xt squared plus yt. The yt is the x value at the turning point. The t means turning point. The xt, sorry, is the x value at the turning point. The t means turning point, and the yt is the y value at the turning point. All right. So this is, we call it a turning point form because you get the coordinate of the turning point. It's a quadratic function that will have a smile shape, and with this now form, we get in the turning point coordinates xt, yt. All right. The yt value is also the minimum value of the function. It's the minimum value. That works out to be the minimum value. Sometimes the question will also ask for an axis of symmetry, the vertical line there. And the equation is always x equal whatever the xt value is down here, x equal to xt value. And that's why we like to do it this way, because the part 2 and the part 3 is always something relating to the xt or the yt. All right. So for the persons who are not in our class normally but are online watching, bear that in mind. All right. Have some new persons online watching. All right, so we're going to go and do this question our normal way. So let me use the reading for this part. All you want to do is identify the A, the B, and the C. So remember, the A is not the first value now. The A is the coefficient of x squared. So they're giving us the equation 2 plus. All right, they're giving us the equation like this. 2 minus 8x plus 4x squared instead of this way, right? The A would still be equal to 4 because that's a coefficient of the x squared. The B would still be equal to negative 8 because that's a coefficient of the x. And the C would still be equal to constant term, which is that. So not the A. Some people make a mistake and say the A is the first coefficient and the B is the second one and the C is the third one. Negative 2 you must put here. Right? It is not so. The A is the number in front of the x squared. The B is the number in front of the x, and the C is a constant term. So we have to be careful with these things. All right? I was trying to tell you the mistakes people make all the time. So here it is set out in a friendly manner. So sometimes even people don't really know they get it right. But in this case, the A equals 4, the B equals negative 8. And some people leave off the minus sign. They have to see the minus sign that is there. All right, everything important. And the C equals negative 2. And the XT and the YT you're going to calculate now can be expressed in terms of those A, B, and C. The formula for each one. Just like there's a formula for the H and a formula for the K. But remember now, they give us X plus, we are using X minus. All right, and we're using our formula for XT and our formula for YT. So when it is in that format, right, let's go back to the blue. When it is in that format, our xt is equal to minus b over 2a. If you use h in this question, you would have to put b over 2a. All right, what's the difference? If you're using the H method, we're using the H formula with the plus, it is B over 2A. But if they ever put a minus in the bracket, then the H is no longer equal to B over 2A. So that's the minus B over 2A then. That's why we stick to this format. So don't have that confusion to deal with. All right? And then now, careful with the negative signs here. So put on this minus first. That's this minus, I put it down first. That's that minus. And then now, the B itself is negative 8. So it's minus negative 8 divided by 2 times A, which is 2 times 4. All right, and that basically becomes positive 8 over 8. And so that is equal to 1. All right. Now, I told the students some time ago that when the xt is a whole number like this, you can find the yt value by simply putting the 1 back in the function straight. All right, that's one way to find the yt value. So I'm going to work it out both ways and show you. Right? Usually when the xt come out to be a fraction, we don't bother try to work the fraction in this. So we tend to use the formula for yt. Right? But when it is when the xt value is a whole number like this, you can just put it in there. So let me do it that way. So the yt now would be equal to the f of 1. You put in the 1 in the function, and so it will be 4 times 1 squared minus 8 times 1 minus 2. All right, so basically that is 4 minus 10. Essentially that is 4 minus 10, which is negative 6. Negative 6. Or we could use our yt formula. All right, so or we could use our yt formula. So this one now is we'll put the x value back in the function up here. That's what we did to get it here. Or we could use our yt formula, which is 4ac minus b squared over 4a. And we tend to use this formula if the xt here come out to be a fraction. We don't want to have that fraction to deal with. Just use this formula. So if you're using the formula, yt would be 4 times a, which is 4, times c, which is negative 2, minus a negative 8 squared, divided by 4a, which is 4 times 4. All right, 4 times 4. Now this can be simplified down. All right, let's simplify it down. It will be equal to 4, 4 is 16, and then 16 times minus 2. Negative 32, right? So it will be negative 32. Remember, you're not squaring this minus, so you're going to come back as a minus. That minus not squaring. So you're going to come back as minus, and then you're going to get 8 squared is 64. And after I get that, now you divide that now by 4, 4 is 16. All right, and if we work it down, it becomes minus 96 over 16. And so it still comes back to negative 6 just the same. So you see, when you get a whole number for your xt, this workout, this method is easier than to have to do all of this calculation. All right, so that's why you have to learn those two ways. If you get a fraction for your xt, then that is when you use the formula method. You use this method if you get a fraction for your xt. All right, so in any case, the xt is that value. So we can write this function now. All right, we can write this function now that they want. Basically, we can say therefore f of x is a different color. Let's use the red. So we can say therefore f of x is equal to a. We're putting it in this now. Putting everything in this format now. That's all we're doing now, using that format. All right. So it becomes f of x equals a, which is 4, into x minus xt, which is 1. Don't forget to put on the square, and then the plus yt. The plus yt is negative 6. So the plus yt is negative 6, and that is basically it. Right? Right. All that would happen is ask for the value of h, ah, and k in their thing. You compare this with this. If you compare them, you see that the a is 4. The plus h is negative 1, and so the h is negative 1. and the plus k is -6, and so the k is -6. If they wanted to specify those values, that is what it would be, by just comparing. All right, by just comparing, that is what you would get. Right? In any case, that is that part. All right, moving down. Let's say state the minimum value. So why they say state? Because they say no calculation needed. The minimum value now is this. Now, why is this a minimum value? It's a minimum value because this part that you're adding can only be positive because of the square. This part can only be positive or 0. So you'll always be adding something to -6. So -6 is the lowest value. All right. So basically that is it. So -6 is the lowest value. So you can write it like this: f of x min is -6. If you write it like that, and then we put it is the yt value. It's the lowest y value, which is -6. That's the minimum value, -6. Next part now wants the equation of the axis of symmetry. Remember the curve. If you like to sketch this curve, you can sketch it over here for you. Let's sketch a curve over here. Let's hide this and sketch a curve. They didn't ask us to sketch it, but we have to sketch this curve, right, and show the axis of symmetry. Let's put in the y-axis. Oh wait. So let's put in a y-axis. Come again. Y-axis and an x-axis. If that asks us for a sketch. All right. Then now it turns at the minimum point. Minimum point would be xt yt. So that would basically be 1 -6. So 1 -6 is somewhere down here. So it turns somewhere down there. All right. And then now the next thing you want to know is where does it cross the y-axis. So you know that it turns down here. First, it has a smile shape because the a is positive. So it has a smile shape. Once a is positive, it has a smile shape. Right? It crosses the y-axis at the c value here, the -2. So it crosses the y-axis at -2. So it turns down here and crosses the y-axis at -2 somewhere down there. So that's all you have to do is make a sketch that does that. And so it will go like this. That will be the sketch. All right. And then this point would be 1 -6. Right here would be the y-axis intercept of -2. And the axis of symmetry now is a vertical line passing through here. Axis of symmetry is the vertical line passing through the turning point because the axis of symmetry is divide the graph in 2 equal halves. And the equation of this line now is x equals 1. Because this point, x value is 1 right here, so is 1. And a vertical line through there is x equals 1. This is 1 on the x-axis right here. And so the equation of axis of symmetry is x equals xt value, which is 1. So the only access to the equation of axis of symmetry, and so it will be x equals whatever the xt value is. That equation is x equals 1. That's the equation of that vertical line. X equals 1. All right, easy question. All right, so let's go over to the next part. All right, take your pictures as we go, guys. So I'm gonna clear this now. They didn't ask us for a sketch, but if they did, that would be it. This vertical line is the axis of symmetry. Let's write it. Axis of symmetry is that vertical line, and this is the minimum point. All right, so let's clear this. All right, so now moving up now. To this part. All right. So we'll discuss them now. That's our speed time graph question. So the question says, hold on a second, guys. Just give me a second. Okay. Right. So the question says the speed time graph below, not drawn to scale. So the 3-stage journey of a car over a period of 40 seconds. All right. So if you look at it, so discuss what happened. The car accelerates from rest, meaning it starts at a speed of 0. So it accelerates from rest, and it accelerates uniformly because a straight line acceleration, meaning it is increasing its speed. and it increases speed to 12 meters per second in 16 seconds. All right? And then here now, it's going at a constant speed. So the speed is constant at 12. So it's not changing the speed. So up here now, the acceleration is 0, not increasing the speed. And it does that for 16 seconds because 16 to 32 is 16 seconds. And then here now, decelerates to rest, come back to rest. And it decelerates to rest. So this is decelerates to rest, or retards. They call it deceleration or retardation. So deceleration, or they call it retardation. And deceleration is just negative acceleration. Here we had acceleration. That's what we had here. It was accelerating up here because it was increasing the speed. Here going at a constant speed because it's not changing its speed. Speed is constant, so the acceleration up here is 0, no acceleration. All right, and over here now is 8 seconds. Between 32 and 40, that's 8 seconds. So that's information on there. They're not gonna ask you everything, but you know, it's good to just remind ourselves of those things. All right, so I'm going to clear it off. It's good to just remind ourselves of these things because they can ask you anything. Remember, area under the graph is distance traveled, and the gradient of the line segments is acceleration. When the speed is increasing, the acceleration, here it's coming down, it's deceleration. All right, remember, acceleration means that the speed is increasing. All right, so let's continue with the question now. So it says, determine the acceleration of the car for each of the following stages. Stage 2. Stage 2, the acceleration is 0. Stage 2, the acceleration is 0. For stage 2, acceleration is 0. So the acceleration equals gradient. Acceleration will always be equal to gradient. So the acceleration on stage 2, that's why I call it A2. Acceleration on stage 2 is equal to 0. Because there is no rise. So the acceleration is 0. Remember, gradient is rise or run, and there is no rise. For stage 3, now this one kind of tricky because it asks us for acceleration. But here we really have a deceleration. So we have to go put the negative. You see, the question that asks for the deceleration over here, you wouldn't put the negative. Right? Because deceleration already means that the speed is coming down. Right? But they ask us for the acceleration in stage 3. So again, in stage 3, we already see acceleration equals gradient. So acceleration in stage 3 is rise over run because it's gradient in stage 3. Now the rise in stage 3 is negative 12 because it fell, came down by 12, and then it run 8. So it's negative 12, it came down, and then it run 8. So negative 12 over 8. Negative 12 over 8. All right? And that is acceleration in stage 3 is minus 1.5 and is meters per second squared. Meters per second squared. Why is it meters per second squared? Because the speed that it come down is meters per second. And this down here is second. So meters per second divided by second is the same as meters per second times, because this second over here is the same as second over 1. 1 over second. So it becomes meters over second squared. All right, so that's the reason why it's meters per second squared. But if you just know, then that's it. So anyway, negative, and you have to put a negative on it. If the question had asked for the deceleration over here, you wouldn't put the negative open, but I understand that because sometimes they will ask you for the deceleration or the retardation in stage 3. If they ask for the deceleration, don't put the negative. Because deceleration already means negative acceleration. Everything important. Pay attention to everything. Everything important. All right. So let's go. So those are the answers for that part. Acceleration in stage 3. We call it A3. All right. So let's go to the next part now. Done? So easy. Those of them are really easy now. Can't beat them. Don't ask you no distance, no area, no nothing. Just that's all. Anyway. So all right, so we're going back now to question number 7, right? Question 7. All right, so that's a pattern question. All right, question 7. All right, so this is it. All right, so this question says, sequence of figures is made up of stars using dots and sticks of different lengths. It says the first 3 figures in the sequence are shown below. So we see that, right? So basically, I keep putting another star on the outside, and it's just a larger star to put on the outside. It has the same number of sides and the same number of sticks. It's just that they started with 1 in the middle when they started, and then they keep adding the same number. And we're gonna see that in the table. I'm certainly gonna see it in the table. All right. So question said now, study the pattern, and usually they ask you to draw. What is happening here? The thing stuck. So it's not moving in, I don't know why. Let's see. The thing's, oh, I don't know why. Okay. All right. Let's see. The thing not moving, it's stuck. I don't know why it's stuck. Can't take them technology sometime, you know.
Reach crossroad, come on now, and then we in
What did I do wrong? I don't know, the thing just stop work. I don't know why. Hold on a second, guys. The thing just stop working, I don't know why. Oh boy. No, don't discard. Let's come out and go back in and see. Just give me a second. It's stuck on me and I don't know why it's stuck. Jesus. I'm wondering if the recording is too long because I was trying to record the thing. Oh Lord. Let's see again. All right, come back so we can proceed. All right, so we're here again. All right, good. All right, so let's just study the pattern of numbers in each row of the table. And each row relates to the figure in the sequence, as stated above, and some rows have not been included in the table, right? So basically, they're saying it's an incomplete table. Some of the values not there, but you want to observe now. What I usually tell the students to do is work out the formula down here. So first, all right, we can establish a formula down here and check that it works. Then everything else becomes easy. So you don't have to go do the question trying to figure out stuff and try reason out stuff. Now, if you look at these are just going up by 12. All right, going up by 12. So they're increasing by 12. It means that the formula has 12 n in it. So the figure number is n, the formula relates to the first one by 12n. So 12n is a part of the formula. 12n. So it's either 12n plus something or 12n minus something or just 12n. So I know that my formula is at 12n. Now, to find out whether it's 12n plus something or minus something, I look at the first figure where n equals 1. And if n equals 1, it's going to be equal to 12 already. So you don't need to add anything. So the formula for this column is 12n. Done. All right. So the formula for this column is just 12n. So we can write this column is 12 times n. Then over here now, again, if you notice, it's still increasing by 12. Increasing by 12. This now is the number of dots. Increasing by 12. So again, 12n is a part of the formula because it's increasing by 12. And it's 12n plus something or 12n minus something. So to know it's 12n plus what or minus what, you look at the first figure where n equals 1. All right, now n equals 1 down here. 12 times 1 is 12. You have to add 1 more to get 13. And so the formula therefore is 12n plus 1 for this column. As simple as that. So that is the formula. Then once you know them formula there, you can answer anything after that using the formula. All right. So they want us to complete these columns now. So when n equals 5, it becomes 12 times 5. Simple. 12 times 5. 12 times 5. Or you add 12 to this and get 60. So this is 60. 60. All right. Another observation is that these are all 1 more than these. That's another observation. All right. All right. So this one clearly is 61 because it will be 12n plus 1. This is a 12n and there's a 12n plus 1. It means you add 1 to get this. All right. Obviously. All right. So once you observe those, complete the table. They don't necessarily want to say a lot of working out. You know, just complete the table. And then down here now, so we know that the 12n equals 56. So 56 equals 12n, you know, we want to find the n in this row now, we want to find the n over here. So this equals 12n. 12n equals 56 here, so. So if 12n equals 56, it means that the n over here, so is not 56, 156. It's 156 over 12. So I have to divide by the 12 now to find the n, right? So that is 156 divided by 12, right? So that is 13. So this right here, so now is 13. And again, this is just 1 more than this. So this is 157. And so that finished that right there. So simple as that. Yeah?
Sir, how you get the 12 in again?
Because the figures are all going up by 12. Because you keep adding the same number. You see these pattern questions where you keep adding the same number of items each time, the formula is easier to develop. So if you're adding 3 things each time, then the formula would have 3n in it. If you're adding 5 things each time, then the formula would have 5n in it. And then you look at the first figure for know if it's 5n plus something or 5n minus something. Because you know that in the first figure, n equals 1. So if you look at this one, for example, they're increasing by 12 each time, you know. So we start by saying the formula has 12n. That's what I have here. Formula has 12n. All right, so we'll put on the 12n first. Increasing by 12. And then we look at the first figure, which is 13. In the first figure, n would be equal to 1. Right? So the 12 times 1 is 12. But because the first figure is 13, you know, so we need to add 1 to it. So that basically we know say the formula is 12n plus 1. And then you can try it. You can try it with the other figures. Right? These pattern questions where you're adding the same number of items each time, you can get the formula easily by just doing what I just told you. Easy, easy, easy like that. And once you get the formula, then you can answer any question after that quickly without having to figure out stuff. Some people do it by figuring out stuff. Subtract this first and then this. It does too much work. It's easier to just get the formula and just use the formula. So I always do my part 3 first. All right, I don't try the part 1 and part 2. I always jump to part 3 first. Get the formula first. All right, formula help you to work out things much quicker. I always ask the formula last, but I always do it first. All right, once it's the type where they're adding the same number of items each time, which most of them is like that. Sometimes they give you one way that is not the case, and you can't get the formula that way. You know? Sometimes there's some way you have to square something or some ways to a power, but those are rarely set. The one that they set most often is one that you're adding the same number of items each time. So the formula for those is usually very easy to get. All right, let's look at part B now. So part B says the sum of the number. Hold on, I'm saying something with this thing to the recording. Hold on a second. Okay, it's still recording. All right, good. Don't know how long to record for. Anyway, it says the sum of the number of dots, the sum of the number of dots in two consecutive figures are recorded, and we can see that in the table. The sum of two consecutive figures, all right, are recorded, and these are the dots. It says, I'm talking about the dots, right? It says this information for the first three pairs of consecutive figures are shown in the table below. So it's figure 1 and figure 2. Figure 1 has 13. See here, we can look at it over here. The dots were adding up, right? Remember the formula for down here was 12n. Write it. Remember down here is 12n plus 1. So that formula applies just the same, right? So is 13 and then 25 is the first two figures. And then the two figures after that will be the 25 and the 27. And then the figures after that will be the 27 and the 49. Alright? That's what it will be. And the question said they want us to do for figure 7 and for figure 8. What will be the consecutive figure 7 and figure 8? So what I would do for this, just work out, use the formula for figure 7 and the formula for figure 8 for the number of dots. So for figure 7, it will be 12 times 7 plus 1. That's for figure 7 plus 12 times 8 plus 1. That's for figure 8. I'm going to just work that out. Right? That's the easiest way to do it. So see, that's why it becomes easy if you depend on a formula. So it's 12 times 7 plus, and that's 182. 182 I'm getting. Somebody can check it for me. So that would be,
Correct, sir.
yeah, 15 times 12 plus 2, same thing, right? 182. So that is it, quick like that. And then down you know, they say what is the sum of figure n and figure n plus 1. So basically is when n equals n and when n equals n plus 1. So again, you just run the formula. So this one would be 12 times n plus 1 plus 12 times n plus 1 plus 1. So that's what they're adding now. This should be figure n and this should be figure n plus 1. Simple as that. Right? It's not complicated. And just work it out and simplify. So this will be 12n plus 1 plus inside there will be 12n plus 12 plus 1. And the 12n and the 12n is 24n that. So you get 24n. And then the 1 and the 12 and the 1 make 14. So you get plus 14. And you're done. That's it, 24n plus 14. And we can do, if you want, is check it. Check it with the figures, the first two, just to make sure. So let me look up here, so where the n equals 1, the first figure, where the n equals 1, and try it down here. So it will be equal to 24 times 1 plus 14. And then we get 38. It means it's right, which I do get 38. So that's right. And we try it when n equals 2 here, so just try to just test and make sure so it's right. Just to make sure when n equals 2, when n equals 2, that is this one now, so we get 62. So it will be 24 times 2 plus 14, which will be 48 plus 14, which is 62. So that's correct. So I'm good. Right? The greatest thing is to do a question and know so you're right, you know, in the exam. So you get your formula, run a little quick check, go on again. Right? Worse if you have time in the exam. All right, and that's another thing. We have not started to practice our time management yet. Right? When we know the date of the exam, whenever CXC set the exam for, I will start letting us focus on how we manage the time in the exam. If you're not doing the exam and work. You have to practice time management, right? So it's something we have to deal with at the appropriate time. But anyway, so that is question number 7. That's done. Nice and easy. So let me clear this. All right, so moving on now to the next question, which is now question number 6. All right, question 6. Right, question 6. All right, so question 6 on this page. This way. I'm sure we can see the two of them one time. All right, so question 6. Okay. So question 6, like some trigonometry stuff, right? And some mensuration and anything. Let's see. It said the radius of each of the circles in the rectangle WXYZ shown is 7 centimeters. You can see it. They have it here, 7 centimeters. When I'm reading and I'm looking to make sure that everything they say is on the diagram. You know. Once it's done the diagram, I know that I don't have to read anything again. Anything they say, as it's not on the diagram, I'm going to put it on the diagram. It says the circles fit exactly in the rectangle, and we can see that in the diagram. Show that the area of the rectangle, is 2,252. So to get the area of the rectangle, we need to find this length and this length. Area of a rectangle is length times width. So we need those two lengths, right? And all we know is this dimension, but everything fit perfectly. So since the radius is 7, it means that the diameter of each circle is 14. So let us fill in that information. The diameter of each is 14. We need to know this total length across this. Total length. That's what we need. Total length across here. Alright? So it will be 14 here, so 14 here, so 14 here, so and 14 here, so. And they also need to know the distance down now. Alright, so let's use a different color for that. Alright, let's use a different color for that. Clean this up a little bit. Alright, let's clean this up a bit. Alright, it's just a different color coming down here. So this one now is 14 for this one, 14 for this one, and 14 for this one. So the total length down here is basically 3 times 14. And the total length over here, which we're going to put back in blue, would be 4 times 14. 4 times 14. Alright, so it's 56. This is 56 centimeters. And this is 42 centimeters. Let's write this out a bit better. So we see that this one is 3 times 14, which is equal to 42 centimeters. And since we have those dimensions, we can proceed now and calculate the area of the rectangle. Right, so the area of the rectangle is equal to 56 times 42. And 56 times 42 is correct. 2352 centimeters squared. Now watch me now. If you do all this drawing on your diagram in the exam, they'll accept it as a method of how you calculate. Remember, you know, all this diagram going in back to the exam is a solution. So all that drawing on your diagram, you put all that calculation on your diagram, they will accept it as your method. Right? So you don't have to write anything else. That suffices. That is sufficient. All that marking. So you don't have to go explaining anything down here. Just do that marking on the diagram and then you do the calculation. So your diagram is going in with your solution. Alright, you get your marks by doing that. So you don't have to do anything else. That's good enough. You get the full marks for just doing that. There's only 2 marks anyway. Alright, so you don't have to do anything else. That's it. Alright, next part. Alright, so we know that we could go back and put down the information that we know. We know that this is 42. Let's put it over here in this diagram. Because we're not going to come off the diagram. Down here, so it's 42 centimeters. And across here is 56 centimeters in case we need it. And the area is 2352 3.52 centimeters squared. So we have that information. Let's see now. All right. The next part now says calculate the area shaded. So clearly, the area shaded is the area of the rectangle minus the area of the circles. How many circles there? 1, 2, 3, 1, 2, 3, 12 circles. Did they say that? Did they say it? No, they didn't say it, but it's clearly 12 circles there. But I can say that 4 by 3 is 12. So it's 12 circles. Right? So let's write a formula for the area shaded.
Cool.
Area shaded. Let's write a formula for the area shaded. That's right. So at least we have a method. So there, area shaded equals area of rectangle minus 12 times area of the circle. That's it. The area of the rectangle we know is 2352 minus 12 times the area of a circle is pi r squared. 12 times pi r squared. Let's show the formula for the pi r squared. And then the r is 7. So it becomes, and it's must take pi r 22 over 7. So it becomes 2352 minus 12 times 22 over 7 times 7 squared. So it's 2352 minus 12 times 22 times 7, because one of the 7, this 7 cancels one of the 7 up there. Alright? So when you wrote that calculation, you're supposed to get the answer now. But understand that? 2352 minus 12 times 22 times 7 equals, what did I do? I put plus 2352 minus 12 times 22 times 7. And I'm getting 500. I'm getting 504 centimeters squared. I have to put a centimeter squared. Good? Good. Nice and easy. Let's move on. The next part now says, oh, okay, so we have this thing now. So this is another trigonometry. Once I say that, I know the sine rule, cosine rule coming into play. Right? Because remember, it is a triangle that is not a right angle triangle. So you know that is sine rule and cosine rule right off the bat. All right? So you have to be mindful of that. So come to this diagram now. So let's see what they said. Question says the diagram below not drawn to scale shows triangle MNP in which the angle MPN is equal to angle PMN. So it's 52 degrees. So right away you know it's an isosceles triangle. So these two sides are equal. This side and this side equal. And as you know something, you put it on the diagram. Don't even hesitate. As you know something, you put it on the diagram. So since this side is 12.5, I'm putting it on the diagram. I can't forget if it is there. So this side is also 12.5 centimeters. Anything you know, put it on the diagram right away. So you don't go searching anymore. All right? I didn't tell us this side, no, but you must deduce it because it's an isosceles triangle. Once these two angles equal, then it means that the side opposite this angle must equal the side opposite this angle. All right? Because the two angles are equal. That's how it works. So I want us now to state the type of triangle. It's an isosceles, right? Isosceles. That's it. It's an isosceles triangle. One mark for writing the word isosceles. Next part, determine the value of angle P and M. That's this angle here that I want us to tell them now. This angle. Let's do that angle in red. So I want us to tell them this angle. And that's easy. So an isosceles triangle, and you know those two. Total angle in the triangle is 180. So this angle is 180 minus the sum of those two. And the one right won't finish. Right, so let's put it 180 minus the sum of them. So angle PNM. So what about question? Angle PNM was 180 degrees minus 2 times 52.
52.
Army gone, if you.
Guys, still unmuting your mic. You know how much time mute some of them mic and still unmute them? Guys, you need to mute your mics. If you have something relating to what we're doing, fine. But if you're not talking about what we're doing, mute your mics. Please, I'm not kicking off a group, off a call. All right. So, this is 76 degrees. Put it on the diagram right away. Don't even hesitate. As soon as you know something, put it on the diagram. 76 degrees. All right. So that angle is 76 degrees. I'm going to put it over here. So let's put it over this side. So this angle is 76 degrees. And this is 12.15. This is 12.5 centimeters. All right. So anyway, so let's go now. Next part. Oh, it's on the diagram on the same page. This must calculate the area now of the triangle. So this is not a right angle triangle, so no half base can side business. What we can do is use the trig formula for the triangle. Let's remind ourselves of that. Right? Because we have two sides and an angle between. So we can use the trig formula for the triangle. Right? When you know two sides and an angle between them. So this is A, B. And now the state that the area is half AB sine of theta. That's the formula we're using, right? So therefore, back to this question, right? Here the triangle, area M and P equals. We're using now these two sides and the angle between them, right? That's what we're using. So the becomes half 12.5 times 12.5 is same as 12.5 squared times the sine of the angle between them, which is 76 degrees. You don't have to waste time and work it out piece by piece. You can just type everything in the calculator. So 0.5 is a half. 0.5 times 12.5 squared times the sine of 76. Make sure the calculator is in degrees. Yes, it is. A degrees up. Grade this. Tell me what I get. Somebody work to tell me what you get.
75.8.
180.
You know, sir, I calculate and I gradient. Hold on, then. Give me a second. All right.
Everything's gonna go.
All right, come again. So it's 0.5 times 12.5.
There we get 75.8.
Times the sine of 76.
25.8.
75.8.
Yeah, man. So that's 75.8
Yes, sir.
centimeters squared. All right, good. That question done. Moving right along to question number 5. All right. Question 5. So this is paper not so, but this is January exam gone, you know. So it's very easy. Anybody not get distinction from a paper you want beaten. Just straight A's paper. Very easy. Super easy. They're getting easier and easier and easier. They don't say the exam's challenging anymore. Very easy and straightforward. All right, let's go on this one now. So this one they give us a cumulative frequency curve. Remember, what we said in class is that a cumulative frequency curve simulates us lining up the data in ascending order from lowest value to highest value because the data is grouped and you don't know the actual data. What you know is how many persons score less than a certain marker, stuff like that. So the graph shows how many persons score less than a certain marker, whatever the data is. All right, let's look at this one. It says a group of 100 students. So these are the students up here right away. Students are up here. Right, estimated the mass m grams of a seed. And it said the cumulative frequency curve below shows the results. So these are the students. This is the mass. All right. So the ones who measure the low mass are the ones down here, measuring the low mass down here. The ones who measure the seeds with the high mass are the ones at the top. See, correspond to the ones out here, the higher mass seeds, right? And the data is lined out from the ones who get the lowest mass to the ones who get the highest mass up the top. All right. And this graph shows how many students measure less than a certain mass, or got less than a certain mass, or weighed less than a certain mass. All right, so know what the graph is showing. Question says, using the cumulative frequency curve, estimate. So the word estimate, why is it estimate? Because it is for group data. Cumulative frequency curve is for group data.
Raw data.
Data is because they don't know the actual measurement.
They don't know the actual measurement.
Very good.
Raw data.
Right. So everything is estimating. All right. So they want the median. So remember, these are the students. All right. And you want the median is 100 students. The median is the mass that the 50th student approximately measured. All right. So you're going into the middle student, the one in the middle of the distribution of the 100 students. So basically then, what it means is that the 50th student measured the median mass. So this is the 50th student right here. So we call that the position of Q2. Remember, Q2 is the symbol for median. All right, so just draw your lines across on the graph. If you don't draw these lines, you're not gonna get your marks. All right, so draw your lines on the graph. All right, and read it down. You can see that? You can see that, guys?
Yes,
Yeah.
sir. Yes, sir.
Yes, sir. Yeah.
All right. And that is what I don't dare reading now. Remember now, before you even start to read, before you even do anything, what we should have done first is actually check the scale of the graph. Scale of the graph. On the vertical axis, every line is 2. Everybody can see that? 2,
Yes, sir. Yes, sir.
Yes, sir.
10. Check the scale of the graph before you start to do anything. You don't want, but because you don't check the scale of the graph, you write foolishness. The horizontal axis, every line is 0.2. So that 0.2, 0.4, 0.6, 0.81. 1.2, 1.4, 1.6, 1.82. See that? So the horizontal scale going up by 0.2. And the vertical scale going up by what? Vertical scale, let's write it. The horizontal scale is going up by 0.2. 0.2 scale. 0.2 scale.
And that is going up by 2.
And the other one, the vertical scale is 2, right?
Yes, sir. Yeah.
2 scale. 2 scale. You always want to make sure that you identify that so you don't go and write foolishness. Don't make no sense you're doing the right thing and because you don't check the scale, you write foolishness. So basically then, this is 3.2. Agreed? Every line is 0.1 and right. It's 3.2. Agreed?
Yeah, man, sir.
Good. So the median is 3.2. So the median is Q2 equals 3.2. You have to put the unit of measurement, which is grams. If you don't put the grams, you're going to lose our marks. You have to put the unit of measurement in the data. It's 3.2 grams. You cannot just write 3.2, guys. You have to write 3.2 grams. The median mass is 3.2 grams. All right. Let's move up. Let's move up. I should actually do the drawing over here and do the calculation over that side. But anyway, we'll see it go. If we ever come back, we'll come back. All right. Let's go. The next page. Next page. Next page. I was trying to just do the work over this side this time, and just do the work over this side and then leave the graph there. So that's the median. And the next thing I want is the upper quartile. Remember the upper quartile. The quartiles are the marks. They divide the data into 4 equal parts. So the lower quartile is the position of the lower quartile is 1/4 of the students. The portion of the upper quartile is 3/4 of the students. So the position of the upper quartile is 2, 2. The portion of the upper quartile is what? 75th student will have the upper quartile mark, don't it? 75th student. So remember,
Yes,
every line is 2. So this is 70, 72, 74, 75 is right here. That is 75, don't it?
Yes, sir.
Yes,
Right.
sir.
Yeah.
Yes, sir.
Yes, sir.
75, and that is the position of Q3. Right there is the position of Q3. And then to find the quartile now, you have to draw a cross on the graph. All right? Draw a cross on the graph.
$5.2.
Like that. And then you read it down, right? You read it down like this. And like right in the middle there, don't it? So remember, we're going up by 0.2, right? So this is 4.2, that's 4.3. You better agree with that?
Yes, sir.
4.3,
Yes, sir.
that is Q3, 4.3. Q3 is 4.3. So let's write it. Q3 is 4.3. Right, so there, upper quartile Q3 is 4.3 grams. 4.3 grams. Let me not write like that because you know someone can write good already. 4.3 grams. All right. Next thing I want is the semi-interquartile range. You see that? Semi-interquartile range I want to know. So to get the semi-interquartile range, we have to find the interquartile range and then half it. That's all.
Yeah.
See it? Semi-interquartile range. So we have to go find the first quartile. So I'm going to go back on the diagram now. We have to go find the first quartile. So let's go here now. So the first quartile corresponds to the 25th student. That's 100 enough. 25th. So remember, every line on the vertical axis is 2. That's 20, 22, 24. Right here is 25th, right?
Yeah.
Halfway. So it's basically right here. Read?
Yes, sir.
That is 25.
Mm-hmm.
And the 25
come across
is the
2.2.
position. This is 25.
Q1.
And that's the position. That's not the Q, you know, that's just the position of it. That student
Yes, sir.
has the first quartile mass, right? So
Yes,
come
sir.
down on first quartile mass. You come across on the graph.
2.2. Boy, I like a bright EG zone.
Oh Lord, let's see.
1 2, sir. 2.2.
Yeah, don't joke about the thing, you know. Relax in the step and about to start with the foolishness, you know. Oh.
Can't see.
All right, so right there's Q1. Remember, every line down here now is 0.2. That is 2.3, right?
Yes, sir.
Q1 is 2.3. Make sure you read the scale properly. Q1 is 2.3. Q1 is 2.3. All right, I can write them under here, so. Write them under here. They didn't ask us parity, but I can write them still. So we have Q1 is 2.3 grams. Q3 is what?
4.3.
4.3, what do you say?
Yes, sir. 4.3.
4.3 grams. Good. All right. So that's all we got, right?
Yes,
all right.
sir.
So we could continue now. So the next page now we're gonna write interquartile range. So first we're gonna get the interquartile range. So the interquartile range is Q3 minus Q1. All right. We can just write the formula for the all right. Q3 minus Q1, right? Which equals 4.3 minus what was the other one? 2.3?
Yes, sir.
Yes, sir.
Is equal to 2 grams.
Yeah.
2 grams. Therefore, the semi-interquartile range is the interquartile range divided by 2, which is 2 divided by 2, which is 1 gram. 1 gram is the semi-interquartile range. Next part says the number of students whose estimated mass is 2.8 or less. So less than or equal to 2.8. That's what the graph shows. So all we have to do is read it on the graph. 2.8 or less. So all we have to do, go back up to the graph, and we're trying to find 2.8 or less. All right, the graph will show you how many students measured less than 2.8, less than or equal to 2.8. So it's a less than or equal to the graph we have. All right, so we could go back up on the graph now. 2.8 or less. And use a different color for that one. Use the red. So we're finding 2.8 down here now. Bam. 2.8. So this is 2, 2.2, 2.4, 2.6. This is 2.8. Agreed?
Yes,
But
sir.
agree that that is 2.8?
Yes, sir.
All right.
Yes, sir.
Yes, sir.
2.8. 2.8 is this line right here. 2.8. And then we're gonna draw our line up on the graph. 2.8 is this line right here. All right, it looks like around this one. Oh Lord, what did I do? Oh Lord, making a mess. Oh, all right. So 2.8 looks like about right here. Remember, every line up here is 2, so that's 30, 32, 34, 36, 38, 39. Good?
Yes,
Is
sir.
it?
39 students, so that's 39. All right, so we're gonna write that 39. Right there is 39. All right. Now we'll go back over to the sheet. We did it. Right here. So that's 39. All right. So that number of students less than 39 students. 39 students. 39 students had less than or equal to 2.8 grams. That's what they measure, right? Next part now. So next part now basically is saying we are to use the cumulative frequency curve to complete the frequency table. All right. So what they're doing, they're measuring some blocks of mass, sections of mass. All right. And then say, let's complete the table. All right. So the number of students who measure between 0 and 2, and then 2 and 4, then 4 and 6. So they're going up by 2. So they want to know the various little groupings. They're doing some groupings. All right, do some grouping. So let's do it over this side. All right, so first between 0 and 2, let's show that it is 20. Between 0 and 2 is right here. Between 0 and 2, let me mark it. Hold on a second. Oh Lord, where is it? Where is it? All right. All right. So see it here now, between 0 and 2 is right here. These are the person between 0 and 2. All right. Corresponds to the students down here. See that? 20 of them. What is that?
Yes.
20 of them. That's what I'm getting.
Yes,
20
sir.
right here. So good. And then now between 2 and 4. So between 2 and 4 now, let me erase this. Between 2 and 4 will be this block of students. All right, these are the measurements between 2 and 4. And so it corresponds to the block of students inside here. Students between here and there. So that all of these persons between 2 and 4. And so that is 70 minus 20. So that 70 minus 20 is that 70 minus 20 is 50. 50 students in that block between 2 and 4. And then between 4 and 6, between 4 and 6 now, between 4 and 6 now is this block now right here. So between 4 and 6, let's put it above. Between 4 and 6. So between 4 and 6 now, coming all the way up here. Between 4 and 6. That taking us right there, so. Alright. And that looks like
20.
Let's zoom it up so we can see. You don't reach the top of the line, you know. So it is, you come halfway in between here. Alright, right in between. Like 93 actually, you know. It's a 93. So between 93 and 70 now. Between 93 and 70 is the next block they're talking about. This block of students up here. And so that's 93 minus 70. 93 minus 70. How much that? 23?
Yeah.
23. Alright. And then now between 6 and 8. 6 and 8, they give us 6. Let's go check it. Between 6 and 8, they tell us that is 6. Let's just check it. So between 6 and 8 now will be this block. This block of students, right? Coming up on this line now, between 6 and 8. This line we're on now. Alright, let's zoom in and see what it is. So that's coming right up to here, so right? So it's right in the middle again. Look at it, it's right in the middle again, right here. Everybody can see that?
Yes, sir.
Yes, sir.
Right in the middle there. Let's go across and see that block of students there. Alright, let's see how many of them there. Alright, and that is 99. See that?
Yes, sir.
99. So it's right between 99 and thing there. So them get the 6.
Yes, sir.
It 99 minus 93. And then the last block now clearly competes to 100. See it? And if you add up all of these, then
Yes.
add up to the 100 students. And you can double check it. Add up to 100 students. 20 plus 20 plus 50 plus 23 plus 6 plus 1, 100 students. So that is it. All right, so that completes the table. So they put the students in blocks. All right, it's like the groupings that's like the grouping. So these are the frequencies. All right, and then now, so these are the frequency values. And then now, you say a student is chosen at random. Find the probability that the student estimated a mass to be greater than 6 grams, greater than 6 grams. So I'm going to use the blue for that. So the ones who did greater than 6 grams, started here. See that? Those are the ones who did greater than 6 grams, you know. This was greater than or equal to 6. So you're not including this one out of it. All right? So these are the ones who are greater than or equal to 6 grams, and it's 7 of them, 7 students out of the 100. So you can write it like this: probability for the mass to be greater than 6 grams is 7 out of 100 students. That's it. 7 out of 100. All right. That's that. That question done. Very good.
Yeah.
Yes, sir.
Let me grab the mark. Leave the markings there. I'm leave the markings so you can see. Let's leave the markings. All right. So that's how we get the 6. They gave us a 6, but I'm showing how we got it. All right. So you know everything correct. All right. Let's go. Let's continue now to the next one. We reach question 5. No, that was 5. We reach question 4. All right. All right. Question 4. Okay, so these are functions question. Let's go back over here, clear this, and go and find question 4. All right, let's go question 4 right here. All right, so let's see what this question says. This question gives us that function, and it's a must find f of 4 plus f of negative 4. Easy. So f of 4 plus f of negative 4 becomes equal to, let's put it equal to, f of 4 becomes 2 times 4 plus 7 over 5, and then you're adding 2 times negative 4 plus 7 over 5. See that? So since it's one thing, everything over 5, what will happen? You're going to get 14 over 5. Everybody see that?
Yes,
So
sir.
it's going to be 8 and a minus 8, they wipe out each other. So we're going to have 7 plus 7 over 5. So it's 14 over 5. But I give it that?
Yes, sir.
Yes, sir.
All right, good. Nice and easy. Moving right along. The next part now says, all right, this is the next page. All right, the next page says we have to calculate the value of x for which f of x is equal to 9. So if f of x is equal to 9, we're using this thing. We're using this. This is using this as our f of x over here, right? So if f of x equals 9, you're basically solving 2x plus 7 over 5 equals 9. You're basically just solving the equation there. So first thing we're going to do is get rid of the fraction and multiply the 5 over here. All right, multiply across the 5. And so we're going to get 2x plus 7 equals 45. And we're going to subtract the 7 next. Subtract the 7. I'll subtract the 7. We're going to get 2x equals 45 minus 7 is how much? 38?
Yes, sir.
38, don't it? And
Yes,
then we're going to divide the 2. Divide under the 2. You get
9.
the x now. And when you divide the 2, you get x equals 19.
Supposed to be 19.
Mathematics, nice, man. Easy question, I don't. I like them easy question. I think I don't know. Question will like this. Next part say,
Then question they
hence
open
or
an exam.
otherwise determine f of f to the minus 1 of 9. If the minus 9, I'm gonna be 19, you know. So I look. Let's look. F of x equals 9 right here, so. Right? It means that f of 19 equals 9. Therefore, 19 equals f to the minus 1 of 9. See it?
Yes.
What
Yeah,
is
man,
that?
sir. Makes sense, man.
Right. Right. But let's say you never know that. So I'm going to show the two methods. You say hence or otherwise. So let's do the hence first. Let's do it the
Yes.
two ways, just in case you never know. All right. So let's use a hence method. So the hence method, based on what we did a while ago up there, it means that f of 19 was 9 from up the top. F of 19 equals 9, it means that 19 equals f to the minus 1 of 9. Right? So that gives us the answer. Therefore, f to the minus 1 of 9 was 19. Was 19. Right? The other way, if you never know, we'll have to actually calculate the f to the minus 1 and put in the 9, right? Which is a longer method. So the otherwise method. Otherwise method. Now I prefer to do the ends method in the exam. The ends method always easier. Otherwise method. So the otherwise method, you have to find f to the minus 1. All right? So we're going to find f to the minus 1. We're going to start by saying f equals 2x plus 7 over 5. Whereas leave off the of x for the time being so as not to confuse it, right? Make it simpler. So just call it f for the time being. We'll form the inverse function. When we form the inverse function, the f, which is the range, becomes the domain. And the x here, which is the domain, becomes the range. And so it becomes 2f to the minus 1 plus 7 over 5. And you're basically transposing to make this f to the minus 1 the subject. That's what you're trying to do now. All right, so first we're going to do again is multiply the 5 across here. So you multiply the 5 across, you're going to get 5x equals the color here. It's not really a part of the thing. So to the inverse function. Right, so back to the blue. Right, so the f of x, the 5x will be equal to 2x, no, not x. 2 times f to the minus 1 plus 7. Alright, and you care about the 7 and divide on the 2. You're going to get 5x minus 7 over 2 equals f to the minus 1. Am I agree with that?
Yes, sir.
Yes, sir.
And you can put in back your of x now, right? That was done. We put in back the of x. Alright. I know that we have bring back the of x now. One f to the minus 1 of 9. So we can say therefore f to the minus 1 of 9. We put in the 9 in this now. We get 5 times 9 minus 7 over 2. Which is going to give you what the same 19. Alright. But we don't want nobody do it that way, you know. Right, but it's a practice the inverse function part, right? This is the way you really want to do it. It really shows you know your stuff. All right.
Sir, but
No
that's
problem.
how we do it.
If you have to do it that way here, if you have to do it this way over here, so no problem. All right, no problem. But you're learning, so not an issue. Anyway, let's continue. Next part. The next part now gives us these two lines. All right, find them over here. All right, so give us a graph with two lines here. Let's see. All right, what the question said? Question said, graph below shows two straight lines, L1 and L2. L1 intersects the x and y axis at 4, 0. So L1, note that this is L1. I mark them in red. This is L1 and this is L2. So you don't mix them up, right? 1 and 2. All right, let's see what them say now. Them say L1 intersects the x-axis at 4, 0, which is right here, and 0, 2, which is right there. Good, so we see that. All right, and then them say no, them say L2 and L2 intersect x and y axis at 1.50. That's right, here's the 1.50 and 0, -3. This is 0, -3. All right, so that what they told us up here, you can see it on the diagram. So you know that we can go to the diagram whatever we want. All right, let's see what they want us to do now. They want us to determine the equation of L1. All right, so they give us a graph, you know, L1, and we know the y-axis intercept at 2 already. So all we need is a gradient, right? And to find the equation, we need a gradient and a point. If the y-axis intercept is your point, then it will be easier. You just use y equals mx plus c, so it's only the m we want. So the line is going to be y equals mx plus c, where the c already is equal to 2. So the m we need, right? So let's look on the graph how we can get the m. To find the m, we can just do the rise over run for 2 points. This line going to have a positive or negative gradient. This line is L1 line. Positive or negative gradient you're supposed to get? Everybody, positive or negative gradient you're supposed to get? For that line.
Negative.
Good, guys, sloping downwards.
Mm-hmm.
Go from left to right on this line, you're going down. So it has a negative gradient, right? All right,
Yes,
so
sir.
we can get the gradient easy now. Easy, easy, easy. And you can leave this on your graph on the exam. You can just use 2 points on the graph that we know. So we can say this point to this point.
Yo,
Any 2 points on the graph. Pay attention and stop the talking. Mute your mics. After you answer the question, mute your mic. So to go from this point to this point, you rise -1 and run 2. -1, +2. -1 over 2. So the gradient, so it means that the gradient is -1 over 2. As easy as that. Gradient of line 1 is -1 over 2. So you can leave those markings on the diagram, come back down here, and so the gradient of line 1, talking about line 1 and C1. The gradient of line 1 is -1 over 2. Based on the markings up there. Therefore, the equation is y equals -half x plus 2. Done. Nice and easy like that. We're doing it the easy way. Don't need to calculate nothing when you can look and see the rise and the run. All right. Next part. Do it the easy way. Next part says, what is the gradient of line 2 given that line 1 and line 2 are perpendicular? We can do it 2 ways. Let's do it 2 ways. If they're perpendicular, what happens? Gradient of 1 is the negative reciprocal of the next one, don't it?
Yes,
Know that
sir.
the gradient of line 1 is -1 over 2. Therefore, the gradient of line 2 equals -1 over the gradient of line 1. Negative reciprocal, don't it? Because
Yes.
they're perpendicular. Remember? Perpendicular lines have negative reciprocal gradient. How do negative reciprocal gradient again? What's the quick way to do it? What's the quick way to do this calculation? Huh?
Flip and change sign.
Very good. Flip it and change the sign. So if you flip the negative half, it becomes 2. Change the sign to 2. So the gradient is 2. What is that? Or we could go on the graph. We could go on the graph and look. We could go on the graph and look at it and make sure it's 2 for real, right? So the gradient of line 2 from the graph would be rise from 1 point over run from 1 point to another point. And all you have to do is go on the graph and look and show the markings on the graph for the examiner to see. So let's zoom up again and choose any 2 points on the graph that you know for certain. So let's say we're using this point. Let me use this point
1.
and this point. Any 2
Can
points.
Can you use 6 on?
Huh?
Can you use
Right.
2, 1?
Using these 2 points. You don't have to use the 2 that I use, you know. You have to use the 2 that I use. I'm just choosing any 2 points to show you. Any 2 points you choose to use, it will work. But I'm using the 2 closest points I can find. So I rise 2, run 1. And run 1. Rise 2, run 1. See that? To go from 1 point to another point on the graph. So you put that on the gradient and you write it on the graph. Gradient of line 2 is 2 over 1, which is 2. You put that on your exam paper, mark it, let them see it, you get your marks. Right?
Yes, sir.
Get your marks. And so notice down here, so now I'm telling the examiner that I'm using my graph. See? I'm stating graph there. So you know so my answer is on the graph. So it's 2 over 1, which is equal to 2. All right? So basically that's it. All right, good. Let's go to the next one now. Question 3.
Right.
Question 3. All right, so question 3. All right, good. So, question 3 part. Right here, so. All right, so question 3 give us this diagram now. So the diagram is a hexagon. Hexagonal prism. It's a prism. It's a prism again, an object with a uniform cross section, right? same ends. So this end at the back and this end at the front. I'm shading. Are the ends at the back and the front are the two ends. And then this will be the length. The length is the distance between the two ends. Remember the formula that governs an object like this, if we were doing calculation, is V equals cross-sectional area times the length. And then curved surface area would be the perimeter of the end times the length. That would be the area around the side of the object. Area of faces around the side is the curved surface area. And then the total surface area would be the curved surface area plus the two end areas. Remember, that's the three formula that governs these things if we're doing that sort of calculation. All right, let's see what they want us to do in this one now. Remember these things, we're revising. All right, a uniform cross section. Remember, the area of this end is what we call A. The area of the end is what we call A. And the distance between the two ends is what we call L. All right, remember these things. All right, let's see what they want us to do now. Question says, complete the following statement. The prism has, or they want us to tell them the faces, edges, and the vertices. So Cara came to me with some formula thing the other day. Don't need no formula for this. Just count them. Don't need no formula. Just count them. The faces are the flat sides. Let's mark the flat sides. All right, all the flat sides. So we have a flat side here, another one under here, and another one on the top here. That's 3. And then you have 3 similar sides around here, under here, and under there. So 6 sides around the side, and then 1 at the back, and 1 at the front. The one at the front here, the one at the front. So there's 6 faces. So the answer that is 6 faces. What is that? Easy as that. Don't need no formula for that. Just count them.
Sir, 8.
Sir, it should be 8 because you go cover the
8. 6 and 2.
Oh.
8.
6 side and the 2 at the front and
6 and 2, 8.
Yeah.
All right, and then the edges now. The edges are the straight line between the faces. The straight line between the faces. Let's count them again. All right, so I'm gonna mark them. 1, 2, 3, 4, 5, 6 around the side, right?
yes, sir.
7, 8, 9, 10, 11, 12, and then on the front face, 12, 13, 14, 15, 16, 17, 18. But I get that?
Yes, sir.
18 edges. 18 edges. And then the vertices now are the points where the edges meet. 3 edges meet is a vertex. Right? So just count them. Just mark them. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Good?
Yes.
And easy. Don't make a mistake and write 6 like me. Then 2 make 8. Concentrate. All right. Sometimes you know the right thing and still write the wrong thing. That's how it goes. That's why you have to practice. So you don't know not to make mistakes. All right, let's go. Next one. All right, so this one now. Let's see what this one says now. So this one says a sports club owns a field PQRS in the shape of a quadrilateral, right? So we can see that. It says a scale drawing of the field. So this is a scale drawing. So really and truly you need to be measuring on this drawing in the exam, but I don't have anything to measure. So you'd have to have the actual paper in the exam to measure something, right? Once I give you a scale drawing like that in the exam, they're gonna want you to measure something. But anyway, it says scale drawing of the field is shown, and the scale is 1 centimeter represent 10 meters. So the scale is 1 centimeters to 10 meters. So 1 centimeters on the drawing is 10 meters on actual on the field. 1 centimeter on the drawing is 10. Question says the field is to be divided with a fence from P to RS. So we want a fence over from here, so over to RS, somewhere over from RS, right? That's what they must say. From P to somewhere on RS. From P to RS. So that the different sports can be played at the same time. So that different sports can be played at the same time. It says each point on the fence, so each point on this fence, each point on this fence is the same distance from PQ as from PS. All right, so when I say distance from a line, it's perpendicular distance. Once you hear distance from a line, they're talking about perpendicular distance. So what they're saying is that take a point on this fence, for example. The perpendicular distance from this line PQ must be the same as the perpendicular distance to this one. That's what they want. But understand that? That's what they want the fence to be. So the fence must go from here to here, so it must be such that the distance, perpendicular distance from PQ, once I say distance from a line, it is perpendicular distance. Even if they don't use the word perpendicular, distance from a line is perpendicular distance from the line. So the distance they're talking about is a perpendicular. So at a point on the fence, the distance from PQ and the distance from RS must be the same. That's what they're basically saying. All right? So it means that this length and this length will be the same. You see that? And then now if you look at what is happening, this should be a right angle triangle. This should be a right angle triangle. And this also be a right angle triangle. Now let's analyze what is happening now. Now, if this is a right angle triangle over here, and this over here is a right angle triangle, right? And in addition to being right angle, it use a red ink. A length here and a length here is the same. And then this length is common to the two triangles. Once you have two triangles with two right angle triangles with two sides already equal, then the third side also will be equal. So it means that a side here and a side are equal to. And so the triangle here and the triangle here are two congruent triangles. And if these are two congruent triangles, right? Then the angle here and the angle here already are 90. Then it means that the angle here so and the angle here so must be equal. This angle and this angle must be equal. All right, so the fence have to be drawn such that it bisects this angle across here. That's what will happen. You have to draw the fence so that it bisects that angle. So let me sketch it again. All right, so when you draw a fence from here to here, and the perpendicular distance to any point on this side must be the same distance, perpendicular. Same perpendicular distance on this side. So the length here and the length here must be the same. And the length here is the same for the two triangles. And so the angle here and the angle here is the same. So the angle here and the angle here is the same. Then the line here you must draw has to bisect the whole of the angle here. So you're basically drawing a bisector of this angle. That's what you have to construct. The bisector of this angle. You want to bisect this angle. The fence must bisect the angle here. So all you have to do to construct, the more you construct it, use a straight edge, which is a ruler and a compass. You must construct the bisector of this line. The fence is going to bisect this angle. So how you bisect this angle? And how you do it, get a chance to do this topic in class. So somebody should know to do it, right? You're going to use a compass and open the compass a reasonable length. Open the compass to about out here, so, right? And put the point of the compass here. And then after you put the point of the compass there, what you're going to do, you're going to make an arc like that with the compass. Good? You're going to make an arc. It doesn't be so wide. You're going to make an arc here first to bisect the angle. And after you make that arc, I'm going to put the point here again and put the point here again. And what's going to happen is going to make an arc from this point. You're going to make an arc somewhere in the middle here. And from this point, you're going to make an arc somewhere in the middle there and cross there. And then where those two lines cross, where those two arcs cross, we're going to draw the straight line. We're going to draw the straight line for the fence straight through here, so now. And that's going to be the fence. And what will happen is that this angle and this angle will be the same. And this will be a fence. This red line will be a fence. But understand that?
Yes, sir.
But you have to basically to finish to do this question, you have to bisect the angle here. So you have to bisect this angle. That's what it is. All right, and then you get that, and then after you get that now, what I want you to do next. That's what you have to construct. Hopefully, we get a chance to do geometry construction in the class, right? Because there are certain good things I want to show you. All right, so all know in the exam is we arrange that. Next part they want us to is to write down the length of the fence in meters. So to write down the length of the fence in meters, you have to use your ruler now and measure the length of the line here, or you draw. And after you measure the length of the line, where you draw, you can multiply by 10. Because remember, so the scale is 1 to 10, you know. So let's say you measure the line and come out to 6 centimeters, for example. Let's say you measure the line is 6 centimeters. Let's call a point up here, so N. So where you measure, right? You measure the line. So let's say you measure the line. Let's say the measure it to the ruler. Measure of PM equals 6 centimeters, for example. Let's say measure 6 centimeters. So it means that the fence is 60 meters long. But understand that?
Yeah.
But understand that? Because the scale of the map is 1 centimeter to 10 meters. So every centimeter is 10 meters. But good?
Yes, sir.
So you have to construct it and measure it. I don't know what the actual thing is, you know. You have to do it and measure it on the paper.
74 meters.
I don't have the paper. So you can be able to print out the paper that I sent. Print out the paper that I sent and you can do it.
So in the exam is about
anyway, let's go.
74 meters.
Huh?
In the exam it was about 74 meters long.
So you got 7.4 centimeters when you measure it?
Yes, sir.
And you constructed the bisector of that angle as well?
Yes, sir.
All right, good. So he's saying that he did this guy on the phone you're hearing. He did it. He's actually in Tobago, and he did the exam in January. He got a distinction, right? So it's just you're going through with us again. So he did this question. He bisected the angle and he measured it, and he measured 7.4. And he wrote 74 meters, which would be correct. So if you measure 7.4 centimeters, then the answer will be 74 meters, which would be correct. All right, so when you print out the paper, you can double check that. So just make a note. Well, let's write it on this then. Since he did it, let's write it on this. Let's say it's correct, and let's write it on this. So that at least you'll have the correct thing. All right, so he did 7.4. He did 7.4 centimeters, which basically came out to be 74 meters. Right? It came out to be 74 meters. All right. Thanks, Elijah. Thanks for that. All right. So let's continue now. All right. So let's continue. All right. So we're doing this question now. So this is a transformation question. As you look at this, you know that's what kind of transformation is that?
Enlargement.
All right, and it's a positive or negative scale factor?
Positive.
Why is it positive?
Because
Let me hear.
The image getting bigger, sir.
Yes.
No, why is it positive?
Oh.
Why is the scale factor positive? Remember, the scale factor can be negative or positive.
because
All right, let me remind you, it's positive because they are pointing in the same direction. Remember, when it's negative, they will be inverted and pointing in opposite direction. Next thing, the scale factor is a fraction, or is it a number greater than 1? A whole number greater than 1. Based on you look at this. Huh?
Number greater than 1, sir.
Good. Number greater than 1. I can look at it and know the scale factor. All right, let's go through it though. All right, so certain basic things they want to know before you even start working. So the scale factor is positive and it's a value greater than 1. It's positive because the object and the image pointing in the same direction. If they were inverted and pointing in opposite direction, then the scale factor will be negative and the center will be between them. All right, but let's go. Question says quadrilateral PQRS and its image P prime, Q prime, RS are shown on the grid below. All right, it says write down a mathematical name for the quadrilateral PQRS. Clearly, that's a trapezium, right? That's a pair of parallel sides. So it's a trapezium. Let's write that trapezium. A trapezium. Very good. It has one pair of parallel sides, and so that's a trapezium. Obviously, that's a trapezium. Next part says PQRS is mapped onto P prime, Q prime, R prime by an enlargement. So they gave it away. They told us it's an enlargement. The scale factor is K, and the center of the enlargement is at the point CAB. Using the diagram above, determine the value of A and B and K. So they want us to find the point, center, and I want us to find the scale factor. We can find the scale factor by observation. Let's construct to find, let's look at it and get the scale factor. All we need to do is compare one side and see how much larger one side got by a multiple, right? So if we look at this QR, for example, QR is 1 unit, and Q prime R prime is 3 units. So right away the scale factor is 3. See that?
Yes,
Scale
sir.
factor is 3. The image is 3 times as long. All right. Any other side to look at? This also is 1, and this is 3. 3 times as long. Let's look at another one. This side is 2, and this side is 6. See there? 1, 2, 3, 4, 5, 6. So each of the sides increase by 3. You don't need to waste time and measure this one. Right? In addition to that, what also must be our scale factor of 2. The distance from the center also of 3. The distance from the center must also have a scale factor of 3. Anyway, let's construct to find the center. How do we construct to find the center? What do we do to construct the center?
So you draw the lines.
Draw the line, sir, from
Where they meet.
Corresponding points.
Yes, sir.
Join the corresponding points and extend it, right? Join
Yes,
the
sir.
corresponding points. So we can use Q and Q prime. Let's use Q and Q prime. And then use P and P prime, which is basically on the horizontal line there. P and P prime. All right, so it's looking like right at this point here, so it's the center. But you can see that at that point, let's read the scale properly. Don't just write down, make sure you check the scale. Don't just write down. This is -1, -2, -3, -4, -5. Vertical scale. 3, 4, 5. So the vertical scale going up by 1, horizontal scale going down by 1. So this point is -4, 1. But I give it that?
Yeah.
-4, 1 is the center of the enlargement. And then we're going to make sure by checking. Don't go and check it. Make sure it's right. Because the distance from the center must also have the same scale factor, right? So let's check it. The distance from the center to a point must also have the same scale factor as 3. The sides, the scale factor applied to the sides. The scale factor also applies to the distance from the center. So we can double check to make sure. So from here to here is 2 units, don't it? And so we can check from here now over to P prime. It's supposed to be 6 if this is the correct center. 1, 2, 3, 4, 5, 6. That confirms it. It is actually, that is the center. So don't just accept the center that you see. If you make a mistake, you check it. The distance from the center to corresponding points must also satisfy the scale factor, the value of the scale factor. All right, let's do another point just to make sure. So from here to here, from this point to this point, we rise 1, run 2. So if we're going to triple that scale factor, we're going to have to rise 3, run 6. To go from here to here. To go from O, no, not O, center was C. To go from C to Q prime, we're going to have to, this was rise 1, run 2. Rise 1, run 2. So if you triple that scale factor there, to make a scale factor of 3, you're going to rise 3, run 6. So rise 3, 1, 2, 3, run 6. 1, 2, 3, 4, 5, 6. So you rise 3, run 6. So the scale factor of 3 applies from this point. So you know, so everything goes. So you can accept the answer. Don't just construct and just take what you get. Check it, make sure it's right. And let's clean up right here. So all right, so look proper. All right, so we said this came to here, this came to here. That is the point C. And we say the coordinates of C. Let's use the red, it show better on this diagram. So C is the point negative 4, 1. Negative 4, 1. I remember that they gave this coordinates A, B, right? So A is 4, A is negative 4, and B is 1, and the scale factor is 3. All right, so now that we know those things, we'll just write them down, right? Write them down. Now we can show a calculation for the scale factor. I show a calculation for the scale factor. Remember, scale factor is image distance over object distance, right? Image distance over object distance. So we can say K, let's look at calculation. K equals, let's use the Q and the Q prime. Image distance, Q prime R prime over QR. Q prime R prime is 3 units, QR is 1 unit, so the scale factor is 3. All right, and then C is the point AB, which based on our construction is negative 4, 1, and therefore the A equals negative 4 and the B equals 1. So I've given the value for the K, the A, and the B. All right. All right. Let me ask you something now. Sometimes CXC like to ask this question. All right. Let me put it over there and look at it, right? All right. Let's put it over here on this slide over here. Sometimes CXC like to ask this. All right. And you tell me what the answer is. So I'm going so far. Oh, so we're going forward. Right. Right. So sometimes CXC will ask you a question like, let me show you, like, for example, what is the area? I'll show you. I might ask you something like, what is the area of P prime, Q prime, R prime, S prime over the area of P, Q, R, S. And I ask for the value of that. What will be the value of that? Huh? What will be the value of that? Area of P, Q, R, S, P prime, Q prime, R prime over P, Q, R, S. What will be the value of that?
3.
Huh? No.
3.
We're talking about area. No. It is wrong. And make this be the last time. You need to study a must-know sheet. The ratio of the area is K squared. Remember this. Area of image equals K squared. K squared times the area of the object. See that? So if you divide by the area of the object, you're going to see that area, therefore, what's happening here? Pen gone. Oh, all right. Therefore, area of image over area of object equals K squared. So this equals K squared, which is 3 squared, which is 9. So whenever they bring in area, you have to remember this thing. It's on the must-know sheet. You know, study the must-know sheet. Once they bring in area, is a K squared relationship, right? I tell you all the time. When it comes to length, see it here, length of image equals K times the length of object. That's for distance. But when it comes to area, it's a squared relationship. And we did it in class. We explained why it was squared in class. And I'm going to go over it again. Area of image is K squared times the area of the object. So what they'll do sometimes, they ask for the ratio by dividing the area of the object under here. Right? And when that happens, it just simply comes to the ratio is K squared. Area of the image over the area of the object is K squared. You guys have to remember this thing. Right? It's on the must know there. The worst thing, you know, is to somewhere up on the must know sheep come and not can do it, you know. The worst thing ever. Need to be studying the must know sheet you want to get from December. And start with foolishness. All right. Anyway, let's go. Next part. Question are done. Question 2. Make sure to remember these things. You know, we don't know what coming on the exam, but these are things I ask all the time. All right. So make it easy, baby. Question now. This one, so must factorize this thing. So this clearly only has one common factor, which is h. All right. So let's factorize the h out of that. So this basically becomes equal to h into 5h. You can only factor h alone minus 12g. And make sure check inside this if you can factorize it anymore. No, you can't factorize them until you're done. All right. Next one down here is a quadratic to factorize. Let's go through the steps of the quadratics again. Factorizing this quadratics. Remember, when factorizing quadratic, you want to split the middle term. You want to expand it out into 4 terms so you can factorize it by parts. All right. What's the procedure? Let's go. Multiply 2n coefficients. 2 times negative 6 equals negative 12. You want factors of negative 12 that add to the middle coefficient. There's no number there, so it's a 1. You don't say the number there is a 1, so that's actually negative 1. So you want factors of negative 12 that add to negative 1. So you're searching for those factors down here. If you can't see what the factors are right away, you go down the list of factors. So the first factor, remember, as always, 1 and the number, so 1 and 12. Since you want the product of negative 1, you want 2 factors that are negative, and 1 factor will be positive, and you want the factors of negative 12. 1 factor will be negative and 1 will be positive. You're going to give the larger of the 2 factors a sign of this thing up here that you want, which is negative. So the larger factor, you're going to test with the negative. All right? So you're going to make this one negative and make this one positive. And you work out what you get. These add up to negative 11. So no, you don't want negative 11, you want negative 1. So go to the next 2 factors. The next 2 factors will be 2 and 6. Give the larger one the negative sign and the smaller one the positive sign. And then 2 minus 6 is negative 4. You don't want negative 4, you want negative 1. So you go again. 3 and what? 3 and 4. With the larger one, the negative sign, and the smaller one, the positive sign. 3 minus 4 is negative 1. So yes, that's what they're going to use. So what you're going to do, you're going to split this negative x into 3x minus 4x. And then you form 4 terms. So let's do that over here, so now. Back in the blue ink. All right? So ready now. So we're ready to do this now. So this, which is 2x squared minus x minus 6, becomes 2x squared plus 3x minus 4x minus 6. When you split, always check that what you split will give you back the middle term. 3x minus 4 will give you back the minus x, so you know to the right. You want to make that check. For example, if you made a mistake and you put, if you make a mistake and put, for example, 4x minus 3x. 4x minus 3x is plus x, and it's minus x you have, so that pick up so you're wrong. That's why you always do that check after you split. Don't just split and move on. Do the check. Everything important. So the correct thing is 3x minus 4x. All right, so it's 3x minus 4x. If you wanted, you could have put minus 4x plus 3x. Don't matter the order. All right, they're going to do the highest common factor in the first 2 terms. Highest common factor in the first 2 terms is just x. All right, so you factorize the x. X out of this is 2x. X out of the 3x is 3. Remember now, the 2 brackets must have the same thing. So the same thing to do is put by the bracket the term first. You put by the 2x plus 3 first. So you don't make any mistake. But the 2 brackets must have the same thing. And then you look from a negative 4x, you factor down and get a 2x in there. You must have factored out a negative 2. But I say that. You must have factored out a negative 2. It's always positive something or negative something you factor out. Not just 2. You don't just factor out that 2. It's either a plus something or a minus something. You have to be careful. So it's minus 2 you factor out. And the way you do to make sure you check it. You don't just accept what you have. You do a little check. All right, so you do the negative 2 times the 2x, give you negative 4x, so that's good. And then you do the negative 2 times the positive 3, give you the negative 6, you know, so that's good. You do look a check. Now let's do the look a check, I know so everything all right. Then the 2x plus 3 and the 2x plus 3 the common factor now. And so it becomes x minus 2 times the common factor. All right? And so it becomes x minus 2 times your common factor of 2x plus 3. Now, if you just switch these around where you started and put minus 4x plus 3, then maybe you would have gotten 2x plus 3 in front of the x minus 2. It don't matter, it's still correct. Same 2 factors. So it don't matter the order that they come in when you finish. All right? So that is that. So those are the 2 factors. The order that you put them in don't matter. But those are the 2 factors. All right. Everybody good there? All right, let's move on. Next thing. Next question is on the next page. Let's clear this over here. All right. Over here now, they want us to solve. Solve means find the unknown. That's what solve means. Solve an equation. When something says solve, it means you must find the unknown quantity. The unknown quantity in this is the R. So solving for R. To solve for R, you essentially want to make R alone the subject. Make R the subject. You must get a value for R when you're done. All right, that's what solve means. Find the value of the unknown. So to solve for this, you're going to expand and transpose, make R the subject. Basically, either on the left side or the right side, don't matter. So all right, so let's work it now. It becomes R plus 3. I'm going to expand the right side and get 3R minus 15. But I say that 3 times minus 5 is minus 15. Then now I'm going to leave the R to be positive, so I'm going to transpose this over this side. All right, so that the R stays positive. But I don't want to bring the 3R over here and negative and get a negative 3R. All right, so I'm going to just do the easy way. So I'm going to bring this R over here and subtract it. I'm going to take this negative 15 over here and add it. All right, simple transposing. All right, so I'm going to get 15 over here plus 3 equals 3R minus R. But I understand that. Simple stuff. Good. 15 plus 3 is 18. Equals 3R minus R is 2R. And when you divide by 2, you see that the R equals 9. So R equals 9. If I go to that, I can do like a rough check just to make sure. The 9 and the 3 is 12. And then the 9 minus 5 is 4, and the 3, 4 is 12. You do like a quick check, you know, say it's right, you move on. Sometimes you do that, like a quick check when you can. All right, so that is good. Next one up here. Make K the subject of the formula. Just make K the subject. So basically transposing everything away from the K, even the square. I will do it in the correct order. All right, so let's go. First thing we're going to do is move the 3t. So we're left with 5k squared equals 2a minus 3t. What is that? 2a, let's write it a little clearer. Let's go again. So we have 2a minus 3t equals 5 times k squared. But I understand that. I transpose this over this side and subtract it. All right. And then now I need to divide through by the pi. I need to get rid of the pi. Next, I can't have square root yet, you know. I have to square root both sides. I want to bring it to I have to square root the 2 sides. Right? So I'm leaving the square for last. I'm going to divide by the pi. So I'm going to get k squared equals 2a minus 3t, and we divide the pi under it. And then to make k the subject now, I square root both sides. Square root both sides. So I can write, therefore, a equals the square root of the entire thing. 2a minus 3t divided by pi. And when you calculate square root, you should always consider that it could be plus or minus. Now, I think that in this exam, if you put the plus or minus, you get the marks. But if you leave it off, you'll go and get the marks same way. But I would do the proper thing and put the plus or minus. But they didn't qualify anything up here to tell us if it's positive, negative, or not. They didn't tell us anything like that. So the k can be plus or minus the square root. Always do the right thing. All right? So I would do that just to make sure. But they didn't tell us anything about k being positive or anything like that. So that's what I would do just to make sure. Not taking any chance with these people. All right? Whenever you calculate square root and you don't know if something is positive or negative, consider that it can be either positive or negative. Everybody good?
Yeah.
All right, let's move. All right, moving right along. To the next one. All right, so this is the last part of this note. So it says, a farmer plants 2 crops. Farmer plants 2 crops, potatoes and corns, on a 10-acre piece of land. So he's planting 2 crops and he's using 10 acres. He said the number of acres of corn planted is C, and it must be at least, remember the word at least, the term at least means greater than or equal to. At least, if it must have at least $5, it means it must have 5 or more dollars. Plenty people say the word least and put the less than sign. Don't let that happen to you. When you can't remember what it means, just reference it to money. Everybody understands money. Everybody understands how money works. So when you don't remember what at least or at most and these terms mean, just think of money. So just say to yourself, if it must have at least $5, it means it must have 5 or more dollars. So if you must have at least twice the number of hectares of potatoes, it means that you must have that amount or more. And they want us to write 2 inequalities for this scenario. The first inequality is hidden in this statement, It's hidden in this statement that he's planting 2 crops on 10 acres. Because either is going to full up the 10 acres or not going to full up the 10 acres. It can't put more on the acreage than the 10. All right? Or hectares, I should say. So what it means is firstly that the total crops, which is the C plus the P, the total hectares for the crop, has to be less than or equal to the total hectares that he has, which is 10. That's the first inequality. All right? That's inequality number 1. And the second inequality is in this statement that the number of hectares for C must be at least twice the number of hectares for potatoes. So the number of hectares for the corn, which is C, at least means that amount or more. At least means it must be equal to it or more than twice the hectares for the potatoes. And that is your second inequality. But I understand that. But the good, so this is the one that was hidden.
Yeah.
Was hidden. This one was given in a statement. Just that some people go and put the less than sign because them see the least. Remember, don't let that happen to you. When you practice away those things. All right? Remember the mistakes that people make and don't make them. All right, so that ends that question. So those are your 2 inequalities. Nice and easy. Moving right along. All right, so let's go now. So reach question 1. So this one's a bad session at all. Question 1. I've done question. Because I'm one now. If it's the last thing here, so that means the question are done. So question 1 now. All right, so we're done. Let's finish this now and now call it a night. And we see you when we do another paper. So all who didn't do the paper by themselves today, the solutions now, you still need to go and do the paper by yourself. Watching me do it and explaining it will always appear easier than it actually is. They're easy, but for them to become easy for you, you have to also do them by yourself. Right? I'm explaining what I'm doing so it just come across easy. Your brain just process what I'm saying right away and see the reason behind it right away. You have to go now and write the same questions on a blank piece of paper by yourself. If you really want to do well in this exam, people who did not do this paper today, you need to go and do the questions by yourself. Put in the work. All right? Anyway, let's go. You have to have that discipline to the work. You want good grades, you have to put in the work. All right, this question says using a calculator or otherwise, calculate the exact value of this thing. Now, what it means is that since I'm using a calculator or otherwise, it means that I guess you can just put in the values and get the answer. But the important thing here is that this has a multiply here and there's a minus here. You have to follow the BODMAS system, and so you have to basically do the multiplication first before you subtract, right? Multiplication carry a higher precedence over subtraction and addition. So you have to do the multiplication part first, all right? So basically, I'm going to bracket this part to show that you have to do this part first, all right? All right, so you have to make sure. If you type it out as it is in the calculator will work it out for you, But if you're going to work it out step by step, you cannot go do the subtract this, for example, first. You have to do the multiplication first, all right? So we wonder sometimes we don't work with the mixed numbers. We tend to get rid of the mixed numbers and work with improper fractions. So let's work it out step by step. So this improper fraction we work out to 5 times 4, and 1 is 21 over 5, multiplied by a third, and we're changing this improper fraction as well, right? Changing this improper fraction as well, and to be minus 4 times 1 is 4 plus 5 over 4. Good. And then now we're simplifying inside here, and what happens is that this 3 cancels out and give us 1 with this 21, which is giving us 7. Everybody see that? And then now we can work out this multiplication. The 7 times 1 is 7 over the 5 times 1 is 5. And now we have the final result to subtract the 5 over 4. Now when you're doing fractions, you really want the two denominators to be the same. And the easy way to get the two denominators to be the same is to multiply this denominator up here and down there, and then multiply this denominator up here and down there, and the two denominators will become the same. So let's show you what does that mean. I'm multiplying this fraction by 4 over 4, and I'm multiplying this fraction by 5 over 5. And the two denominators will become 20. So this one basically becomes 4 times 7 is 28 over 20, minus 5 5 25 over 20. And know that the two denominators equal. The two fractions are what we call related fractions. When they have the same denominator, they are related. So you can just add the two, work out the numerator, and put by the same common denominator. All right? And so the 28 minus 25 is 3 over a common denominator of 20. And that is it in its exact form. That cannot be simplified any further because this is a prime number. 3 is a prime number. All right? So that is that. All right, so the next part now. So far so good? Body good?
Yeah.
Nice and easy.
Yeah.
All right, this one now we have to use this one now we have to use a calculator. And again, if you're going step by step, you have to work out the squared thing here so first. If you're going step by step, you have to do the power there so first. And after you do the power thing, you work out the numerator and then you divide. Okay, what is happening is that what is happening really is that this is being divided by that, and this also is being divided. The two of them are get divided, right? So, but the same thing to do is work out the whole numerator and then you divide. All right, and you can use the calculator. So, if I'm going step by step, it will be the 4.1 minus. We're going step by step. I'll do the power first, because this count like a multiplication. I will do it first. So it's 1.2 squared, 1.25 squared, which would be 1.5625 over 0.005. And then I work out the numerator, which is to subtract that from 4.1. And that would be 2.5375 divided by 0.005. And then don't have matter of just dividing this now. So I divide this now by the 0.005, and my answer is 507.5. That's what I'm getting. You can double check it for me. see if we get the same thing. All right, so that
Yes,
one
sir.
is that. Next page. The next page now is a stadium currently has a seating capacity of 15,400 seats, right? 15,400 seats. Calculate the number of people in the stadium when 75% of the seat is occupied. Easy, 75% of the total. So this is just 75%, which is 75 over 100 times the total seating capacity of 15,400, and that will tell you how many persons in there, right? So 75 0.75 times 15,400, and that would be 11,550. That's the number of persons in there. It is 75%. Nice and easy question that. Next one said the stadium is to be renovated with a new seating capacity of that. So remember, the original capacity is 15,400, and they're now increasing it to 20,790. All right, so they're increasing it to that. I say after the renovation, what will be the percentage increase? So the percentage increase is basically the increase divided by the original number. It's important that we know it's a percentage of the original number that was there before. Percentage increase is an increase over the original. All right, so let's set it up like this. Let's set it up like this. Let's work on the increase first. The increase equals the final amount, the final number of seats minus the original number of seats. That is the increase, which
5,390.
is equal to
390.
390. I'm sure.
5,390.
390.
5,390, sir.
5,390.
Yeah.
All right. 5,390. Thank you, my dopes. All right. And then now that is the increase, and therefore the percentage increase, and this is where you have to be careful now. The percentage increase than percentage over the original amount, not over the final amount. Percentage increase over the original amount is the increase of 5,390 over the original amount of 15,400, and you multiply that by 100. A percentage increase over the original amount. All right, so you do that calculation then here. 5,390 divided by
37.
30 much?
35.
35%.
All right. It is equal to 35%. But I agree with that?
Yeah.
35%. Good?
Yeah.
All right, nice. Moving right along. Next one. So next one now says, a neon light flashes 5 times every 10 seconds. All right, it's like a ratio, you know, a ratio thing. Listen. 5 times in 10 seconds. See, we can set up as a ratio right now. 5 times 2, 10 seconds. All right, that is the relationship between the number of times it flashes and the time. So from that, we know it says 1 to 2. 1 time to 2 seconds, right? We can do any combination, any way we want to adjust this ratio up or down, we can do now. That's the relationship. Now we need to do with this ratio now is multiply it or divide it based on the information that we're trying to find. All right, they say, show that the light flashes 43,200 times in 1 day. So this guy we have to convert the time to day. So if we multiply it up until we reach a day, so let's go step by step. All right, let's go step by step. Let's carry it up to a minute first. Let's carry it up to 60 seconds with a minute. We multiply by 6 first. Let's go step by step. Multiply by 6 first. We multiply by 6, we're going to get 30
times a
We're going to
minute.
get 30 times to 60 seconds. And the 60 seconds is really 1 minute, don't it?
Yes, sir.
And then now one carry it up to an hour, right? So to carry it up to an hour, now multiply by 60. Agreed? Multiply
Yes,
by
sir.
60 now, carry it up to an hour.
1,800.
So multiply now by 60. multiply by 60 now. We're going to get what? 1800 that?
1,800.
1800?
Yes, sir.
Yeah, 1800. 1800 times. 1800 times in 60 minutes. And the 60 minutes now is really 1 hour, don't it?
Yeah.
And the 24 hours make a day, that's all.
Yeah, times
So
by
to get it
24.
up now for reach
Times it
the
by
day now,
24.
multiply by 24 now, don't?
Yeah.
Multiply by 24 now, forget it up to 24 hours. So multiply the 1800 by 24, supposed to get the answer what them say.
22,200.
Good. So we get 43.
200.
Get it now in it, so it come out. So you get 43, 200 times 2, 24 hours, which is 1 day. Which is 1 day, and that's it. Answer. Are shown. You can write shown. You have shown it. That is the answer, shown. And that is that. Is that. Yeah. All right, guys. I think we had a nice session. All right. We had a nice session today. So we really want to send some more work. Keep working. Keep studying the must-know sheets. Practicing. I'm going to send some multiple choice and stuff. Let us try and see if we can do another mock exam on the weekend. All right. We want to do another mock exam on the weekend. At least 1 or 2 more mock exams by the end of this week. And we have to keep pushing, keep working. More math equals better math every time. All right. So I end it there. All right. So those who are not here can share the pictures that they took with them. All right. See, anybody can help. Anybody can explain stuff too. When you explain it to somebody else, it's better for you. So anybody who was not here, just go and explain it to them. All right. So I'll communicate with you in the group and let you know what to do next. All right, guys.
Yes, sir.
Have a
Yes.
good night. All right. Cool.
Yeah.